Ho guys! Tonight we journey back to a world before glowing phone screens and satellite maps, when the night sky was the only clock, calendar, and GPS humanity had. Before we learned to split atoms or send probes to Mars, people looked up, squinted at the stars, and somehow mapped the entire cosmos using stone, papyrus, and a lot of stubborn curiosity. So, dim the lights, maybe crack open a window for a cool breeze, and let's take a slow walk under the as you'll soon see, is kind of the point tonight. Picture this. You're an Egyptian farmer 4,000 years ago. The Nile shimmering in moonlight. You don't have a phone alarm, a wall clock, or even a sundial yet. But you know that when the star Sirius, Sopdet to you, rises just before dawn, it means the floods are coming. That single point of light in the pre-dawn sky tells you when to plant, when to harvest, and when to brace for the river's chaos. You imagine relying on that, your livelihood, your survival, all guided by a pinprick of light in the heavens. It's humbling, right? But also kind of brilliant. Across the world, people were doing the same. Stone circles in Britain, ziggurats in Mesopotamia, and bone-carved calendars in caves. Every culture that looked up saw a story written in glittering code. The difference was how they learned to read it. The Egyptians turned stars into divine messengers. The Babylonians saw them as the paperwork of gods, records to be interpreted, analyzed, and sometimes manipulated. And the ancient Chinese? They were celestial bureaucrats before bureaucracy was even cool. They catalogued the heavens so meticulously that some of their star charts are still accurate today. Let's talk about those Egyptians first, though, because they weren't just building pyramids. They were basically building observatories disguised as tombs. The Great Pyramid of Giza, for instance, isn't just a random pile of limestone. Its internal shafts point almost precisely toward certain stars, including Orion's belt and the North Star. Not because it looked pretty, but because those alignments were cosmic signatures, symbolic doorways for the pharaoh's soul to ascend to the heavens. And they did all this without telescopes, GPS, or laser levels, just sight lines, shadows, and a deep obsession with the sky. The thing about ancient astronomy is that it wasn't a hobby. It was survival, religion, and politics rolled into one. When the high priest of Ra said it was time to celebrate the heliacal rising of Sirius, you didn't argue, because that event didn't just predict the Nile flood, it symbolized renewal, divine order, and the cosmic rhythm of life itself. If you misread the heavens, You didn't just mess up your harvest, you risked offending the gods. No pressure, right? Meanwhile, in Mesopotamia, things were getting mathy. The Babylonians weren't content with poetic symbolism. They were record keepers. Clay tablets etched with cuneiform numbers tracked lunar phases, planetary movements, and eclipses. They noticed patterns. Jupiter moved in cycles, Venus vanished and returned on schedule, and the moon had moods like a teenager. They started predicting celestial events with eerie precision, and that's when astronomy turned into something dangerously close to science, or at least the ancestor of it. But let's not romanticize it too much. The same people who charted the paths of planets also thought those planets were gods sending cryptic messages about your future. A solar eclipse? Not a cool photo op, a bad omen. The king's astrologers would frantically scribble interpretations. If the sun is eaten, the ruler will die. And sometimes, to cheat fate, they'd install a fake king as a decoy. Imagine being the poor guy chosen for that gig. Still, those early stargazers achieved something profound. They started thinking in terms of cycles, not chaos. They realized the universe had rhythm, repetition, and maybe even rules. And once humans realized that, everything changed. Agriculture stabilized, calendars emerged, and suddenly we weren't just reacting to nature, we were anticipating it. The sky became the ultimate spreadsheet. Over in ancient China, similar things were happening, but with their own distinct flavor. Court astronomers, working under strict imperial supervision, kept celestial logs so detailed that modern astronomers still use them to verify ancient comets and supernovae. If a star appeared where none had been before, that was serious business. It could foretell the rise or fall of dynasties. Think of it as the world's oldest political weather forecast. But all of this, the temples, the pyramids, the clay tablets, boil down to one obsession: understanding time. Because once you could predict the heavens, you could predict the seasons, the floods, the harvests, and the rituals. You could impose order on chaos. You could make the unpredictable predictable. And yet, despite all that order, there was mystery too. People didn't just see stars, they saw meaning. The sky wasn't empty space. It was filled with gods, monsters, heroes, and cosmic drama. To them, astronomy wasn't cold science. It was a conversation with eternity. So tonight, as you listen and picture these ancient astronomers squinting at the stars through sandstorms or misty valleys, remember, they were trying to solve the same riddle we still chase today. What's out there, and what does it mean? Next, we'll step inside the temples and ziggurats, where the earliest sky watchers worked their magic, turning observation into architecture. and celestial patterns into power. Deep inside the temple walls of ancient Thebes, the night was anything but silent. Imagine flickering oil lamps casting golden light across sandstone carved with hieroglyphs, priests pacing slowly, chanting rhythmic verses that mirrored the movement of stars above. The ceiling wasn't just decoration, it was a map, a cosmic ceiling charting constellations in blue and gold. Those weren't just pretty dots. They were the gods themselves, immortalized in pigment and stone. When you look up at those ancient feelings, you're basically staring at the world's first planetarium, only built 3,000 years before anyone thought to charge admission. The Egyptians didn't just admire the sky, they built with it. Every wall, every avenue of sphinxes, every temple axis aligned with celestial events. The temple of Amun-Ra at Karnak, for instance, was designed so that on one precise morning each year, the rising sun would pierce its central corridor and flood the sanctuary with light. Imagine standing there thousands of years ago as the first beam of dawn hit the statue of the god, a cosmic spotlight engineered by human hands. It wasn't coincidence. It was a declaration of control over time itself. And while the priests were busy aligning temples, ordinary Egyptians were watching the stars too. Their calendar was no simple thing. It was built around a triad of seasons: flood, growth, and harvest, anchored by the sky's rhythms. The civil calendar of 365 days was born not from guesswork, but from observation. When Sirius reappeared, the Nile followed soon after. That pairing between heaven and earth was their heartbeat. You could call it astronomy, but to them it was divine clockwork. Now shift eastward. Mesopotamia, Babylon, where the nights were clear, the stars sharp, and the scribes relentless. They didn't carve gods on walls. They pressed symbols into clay. Each tablet was a snapshot of the heavens, dated, cross-checked, and archived. These weren't hobbyist stargazers. They were the accountants of the cosmos. Every appearance of Venus, every eclipse of the moon, every wandering of Mars, they logged it all. And through this obsessive bookkeeping, they discovered something revolutionary. The sky repeats itself. Patterns emerged, and prophecy turned into prediction. If you could predict an eclipse, you could predict divine anger, or better yet, prevent it. That's where astrology entered the chat. The Babylonians started linking celestial cycles to human fate. Born under Jupiter? Prosperous. Born under Saturn? Good luck. It's the same basic logic that still drives half the internet's horoscope memes today, just with fewer emojis and more clay dust. But behind the mysticism was real data. These people were making mathematical models of the cosmos when most of the world was still figuring out the alphabet. Over in China, the imperial astronomers took this even further. Their sky wasn't just for storytelling, it was a political instrument. The emperor was known as the Son of Heaven, and the heavens were his legitimacy check. If the sky misbehaved, a comet, an unexpected eclipse, it meant the ruler's virtue had fallen out of sync with the cosmos. So, naturally, the astronomers had a pretty stressful job. One missed observation, and suddenly your report caused a rebellion. No pressure. But the precision they achieved is jaw-dropping. The Chinese star catalog from 350 BCE recorded over 800 stars with positional accuracy that modern astronomers find shockingly good. They had names, brightness ratings, and constellations distinct from the Western ones, structured around myth and morality instead of Greek heroes. Their records helped modern scientists date supernovae and trace long-period comets. It's like the universe's diary written on silk instead of parchment. Across continents, people started turning their stargazing into architecture. Stonehenge in England, for instance, wasn't just a giant rock circle for summer solstice parties. It was a functioning observatory. The stones align perfectly with the sunrise on the longest day of the year. Thousands of miles away, in Central America, the Maya were doing the same thing with stepped pyramids, aligning temples to the equinoxes. There's something universal about humanity's urge to make time visible, to carve the invisible order of the sky into the landscape. Now imagine what this meant to daily life. If you were a farmer in Babylon, your planting season depended on lunar cycles. If you were a priest in Egypt, your rituals synchronized with the rising stars. If you were an emperor in China, your authority literally came from celestial harmony. The cosmos wasn't a distant mystery. It was the foundation of everything practical and political. Timekeeping wasn't just about counting days, it was about power, and that power wasn't abstract. Controlling calendars meant controlling festivals, tax collection, and agricultural planning. It meant knowing when to start the flood defenses and when to celebrate the gods. If you controlled time, you controlled life. And the ancient sky watchers, those priests, scribes, and astronomers, were the hidden architects of that control. They turned the spinning of the heavens into the first bureaucracy. So, while you might think of astronomy as modern science, for the ancients it was far more intimate and immediate. The sky wasn't just above them, it was within everything they built, believed, and feared. The stars weren't distant suns. They were active participants in human destiny. And slowly, as the centuries rolled on, those observations began to hint at something even more dangerous. Maybe the gods weren't behind the stars' movements after all. Maybe the universe ran on laws, not whims. And that, as you can imagine, was the beginning of a revolution. One written not in blood or bronze, but in the quiet, meticulous ink of starlight. Let's linger for a moment on that dangerous thought, the idea that the heavens might follow rules instead of moods. For ancient priests and kings, that was both thrilling and terrifying. Because if the stars weren't gods, but gears, then maybe humans could learn to turn them, or at least read their motion. You could say that the earliest scientists were born the moment someone dared to look at the sky and whisper, "What if this isn't magic?" That whisper would echo through centuries, bouncing between temples, observatories, and dusty scrolls. Take Babylon again. Their astronomers weren't just pattern spotters. They were proto-physicists, in a sense. They noticed that planets didn't wander randomly, but danced in repeating loops. They divided the sky into 12 equal zones, what we now call the zodiac, and used it as a celestial coordinate grid. Sure, they thought it revealed divine messages, but in building that framework, they created the backbone of modern astronomy. And here's the kicker. They did it using base 60 math. That's why we still divide an hour into 60 minutes and a circle into 360 degrees. You can thank some sunburned scribe with a reed stylus for that bit of legacy. Meanwhile, Egyptian astronomers weren't far behind. Their temple architects were precision freaks, aligning monuments with stars whose positions they tracked night after night. There's a papyrus fragment known as the diagonal star table, basically an ancient star clock that charted which constellations rose on which nights throughout the year. It's not just decoration, it's data. Each diagonal line represented the rising of a star at a specific hour of the night. Think of it as the world's first spreadsheet for bedtime. And then there's the obsession with balance, Ma'at, the Egyptian concept of cosmic order. To them, every sunrise, every flood, every celestial event was proof that the universe followed divine balance. The priests weren't just reciting hymns, they were performing maintenance on the cosmos, making sure the universe didn't fall out of alignment. So yes, astronomy was a secret science, but also a moral duty. Imagine living in a world where, if the stars went off script, people thought it was your fault. Let's hop back to China for a second, where astronomical precision wasn't just intellectual, it was political currency. The imperial observatories were like the NASA of their time, but with silk robes instead of lab coats. They built enormous instruments, armillary spheres, water clocks, bronze sighting tubes to measure the heavens, and they did it with terrifying accuracy. The famous astronomer Zhang Heng, around 120 CE, designed an instrument that could track celestial objects' coordinates in real time. He even built an early seismoscope to detect distant earthquakes. Picture that, a guy in the 2nd century casually inventing precision devices while Rome was still busy with gladiators. What makes ancient Chinese astronomy so fascinating is its dual nature, part spiritual, part systematic. They saw the sky as a mirror of the empire. If a comet appeared, it wasn't just cosmic graffiti, it was a divine comment on imperial performance. And so, astronomers became the emperor's most trusted and feared advisors. Their job wasn't just to watch the stars, it was to interpret them, like celestial auditors checking the moral ledger of the world. Across the Mediterranean, the Greeks entered the story, and things took a sharp philosophical turn. They inherited the sky maps of Babylon and Egypt, but added something radical: geometry. Thales, Pythagoras, Anaximander, they all stared at the same stars, but started asking new kinds of questions. Instead of, "What omen does this mean?" they asked, "How far away is that?" and "What shape is the earth?" And here's the twist: many of them knew it wasn't flat. Eratosthenes, working at the Library of Alexandria, measured the Earth's circumference using nothing more than shadows, math, and brain power. He got within a few hundred miles of the true number. Over 2,000 years ago, the Greeks transformed stargazing into theory building. They used reason as their telescope. Aristotle argued that the heavens were perfect spheres moving in eternal harmony. Ptolemy, centuries later, built a full-blown model of the cosmos with Earth at the center and planets orbiting on crystalline spheres. It was elegant, beautiful, and utterly wrong, but it worked well enough to dominate astronomy for over 1,000 years. And to be fair, when you look up at the night sky without a telescope, it does feel like everything revolves around you. Sometimes bad models survive, not because they're right, but because they feel right. Still, Greek astronomy wasn't all ivory tower speculation. Sailors used star charts to navigate, farmers used lunar calendars to plant, and architects aligned temples with celestial events, just like the Egyptians did. The stars weren't just philosophical abstractions, they were practical tools. And while philosophers debated orbits, craftsmen built devices to model them. The Antikythera mechanism, found in a shipwreck off the Greek coast, is a stunning example, an ancient analog computer that could predict eclipses and planetary positions using a system of bronze gears. That's right, ancient Greece had its own pocket-sized planetarium, except it was made by hand, not 3D printed. What's striking through all this is how astronomy evolved from pure wonder into pattern recognition, from myth into math. But even as humans mapped the cosmos with increasing precision, they still couldn't resist wrapping those stars in stories. Orion wasn't just a constellation, it was a hunter. The Milky Way wasn't a spiral galaxy, it was milk spilled by a goddess. For every diagram in sand, there was a legend carved in stone. So as we move further into this story, keep this paradox in mind. The more people understood the universe, the more they needed it to mean something. And that tension between science and symbolism, measurement and myth, would shape everything from the building of temples to the birth of astrology, and later, the birth of real science itself. Because when you look at the stars long enough, you either start charting their motion or wondering what they're trying to tell you. By the time Greek thinkers started arguing about the shape of the universe, something extraordinary had happened. Humanity had gone from fearing the sky to dissecting it. The heavens were no longer just a divine stage for gods to strut across. They were a system, a machine, a puzzle to be solved. But that realization didn't make the stars less magical. If anything, it made them even more seductive. Because now, instead of waiting for divine messages, people could decode them. And once humans figured out they could measure the cosmos, well, there was no going back. Picture the ancient library of Alexandria at its peak. Rows upon rows of papyrus scrolls, mathematicians debating under oil lamps, sailors and merchants from across the Mediterranean swapping navigational tricks. Somewhere in that mix, a scholar was probably hunched over a scroll, tracing star paths with an ink-stained finger, muttering about the movement of Mars. The air smelt of ink, papyrus dust, and ambition. This was where the sky turned into science, literally. Alexandria was the Wi-Fi hub of the ancient world, only with more cats and fewer passwords. Let's not forget how radical these ideas were. The notion that the Earth was a sphere floating in space, that wasn't just counterintuitive, it was blasphemous in some corners. It undermined entire religious frameworks built around the heavens being a perfect, unchanging dome. Yet here were philosophers like Aristarchus of Samos suggesting that the Earth moved around the sun. Imagine dropping that bombshell over dinner in 250 BCE. Past the olives, and by the way, the planet we live on isn't the center of anything. You'd clear the table faster than a bad family reunion. But that was the beauty of the Greek world. Their best minds thrived on disagreement. They weren't afraid of being wrong, as long as they were thinking. And because of that, they made leaps that would echo across millennia. Hipparchus, for instance, noticed that the positions of the stars shifted over time, a phenomenon we now call precession. He even invented the concept of magnitude to measure star brightness. 2,000 years later, astronomers still use his system. That's how far-reaching his scribbles in the sand turned out to be. Meanwhile, back in Babylon, astronomy had evolved into something resembling an institution. Scholars there continued refining their tables of planetary motion, combining observation with arithmetic progressions to predict celestial events. They weren't using telescopes, just naked eyes and centuries of accumulated data. But their predictions were so good that later Greek astronomers, including Ptolemy himself, borrowed their models wholesale. Ancient intellectual plagiarism? Maybe, but at least it was productive plagiarism. And while scholars debated the heavens, ordinary people lived under them in rhythms shaped by those very discoveries. Farmers in Greece used lunar cycles to schedule sowing and reaping. Sailors navigated by the stars long before compasses existed. Fishermen on the Aegean coast knew that tides and moonlight dictated their catch. Astronomy wasn't confined to scrolls. It was embedded in the smell of the sea, the turning of soil, the chanting of priests, the timing of festivals. It was daily life made celestial. Now let's talk about Egypt again, because the marriage of heaven and earth there was more theatrical than anywhere else. The temples at Dendra, Edfu, and Luxor were not just houses of worship. They were observatories disguised as sanctuaries. Priests would climb to the rooftops at night, wrapped in linen, to measure the rising of certain stars with sighting rods and water clocks. Their records became religious texts, and those texts dictated everything from harvest timing to royal coronations. Even the pharaoh's legitimacy was cosmic. His rule symbolized balance between the heavens and the world below. Lose that balance and chaos, Isfit, would creep in. Every society had its version of that fear, that if the celestial order collapsed, the world would follow. The Babylonians feared eclipses as omens of royal death. The Chinese feared comets as signs of dynastic decay. The Egyptians feared that the sun might not rise if rituals faltered. It's fascinating and a little chilling how the earliest astronomers carried not just knowledge but responsibility. They weren't just scientists, they were cosmic custodians. And then there were the tools. Before telescopes, people relied on some ingenious gadgets. The gnomon, a fancy term for a stick in the ground, helped measure shadows and track the sun's motion. Water clocks dripped away the hours through regulated flow, giving priests the precision they needed for rituals and observations. The Greeks developed armillary spheres, metal rings representing celestial circles, turning abstract geometry into something tangible. If you've ever used a globe or seen an orrery spinning planets around the sun, you're looking at the great-great-grandchildren of those devices. Yet, despite their growing sophistication, every ancient astronomer hit the same wall. They could describe the sky, but not explain it. They could predict when an eclipse would occur, but not why it happened. They could measure planetary paths, but not understand gravity. For every answer they found, the universe whispered back 10 more questions, and still they kept watching, because even then they sensed that the heavens weren't just patterns, they were principles. So picture that moment. Somewhere in ancient Greece, a philosopher stares into the night, wondering whether those stars are fixed to crystal spheres or suspended in infinite space. Across the sea, in Babylon, a priest marks the slow drift of Venus on a clay tablet. In Egypt, a temple architect aligns his construction to a rising star. None of them knew each other, yet all of them were doing the same thing, listening to the rhythm of the universe and trying, in their own language, to make sense of it. They didn't know it yet, but they were setting the stage for something far greater. Because soon those scattered sparks of insight would converge into the first systematic models of the cosmos, maps of the infinite, drawn by hands that had never left the earth. Let's step forward a little into the late classical and early Hellenistic world, when human curiosity hit a kind of fever pitch. By now, the stars weren't just points in light or divine signatures. They were coordinates in a system that demanded decoding. If you walked through Alexandria in, say, the 2nd century BCE, you'd hear the hum of knowledge being built. Scholars from Greece, Egypt, Babylon, and beyond were pooling their discoveries, translating, arguing, and, most importantly, writing it all down. The universe was no longer just to be observed. It was to be mapped. Think of it. In the Library of Alexandria, thousands of scrolls recorded celestial observations going back centuries. The place was like an ancient data server, full of fragile backups of human understanding. And out of that archive came one of the most influential minds in all of astronomy, Claudius Ptolemy. Around 150 CE, Ptolemy compiled everything known about the heavens into one massive work, the Almagest. It became the textbook of the cosmos for over 1,000 years. When monks, caliphs, or scholars talked about astronomy in the Middle Ages, they weren't quoting Aristotle. They were quoting Ptolemy. His model of the universe was earth-centered, sure, but it wasn't simple. To explain why planets sometimes seemed to move backward in the sky, what we call retrograde motion, he imagined them traveling in tiny circles called epicycles while orbiting the Earth. It sounds messy, but it worked. For centuries, it was the gold standard of celestial explanation. Ptolemy's math could predict where planets would appear to astonishing accuracy, even if his physics was totally wrong. Sometimes elegant math can make a flawed worldview feel invincible. Meanwhile, in the practical world, astronomy wasn't staying locked in libraries. Sailors relied on the heavens more than ever. The Mediterranean had become a busy web of trade, and knowing the stars meant knowing how to get home. The North Star was every sailor's best friend. The position of Polaris in the sky told you your latitude. Its steadiness made it a kind of cosmic compass. The Phoenicians had mastered that trick centuries earlier, using the night sky to cross vast distances without getting lost. They didn't need maps, just the Milky Way and memory. On land, astronomy had another use: timekeeping. The Greeks and Egyptians both refined their calendars to astonishing precision. The Egyptian solar calendar of 365 days was so reliable that the Romans later adopted it. And when Julius Caesar reformed it into the Julian calendar, he basically just tweaked Egyptian math and called it progress. Every time you glance at your phone and see the date, you're staring at a descendant of those Nile-based star cycles. It's humbling how much of our modern world still ticks by ancient clocks. But astronomy wasn't just a science, it was a spectacle. Picture a public festival in ancient Athens where priests and astronomers unveiled a new sundial or water clock, showing citizens how to read time from shadows or dripping water. Imagine the awe of seeing mechanical models that mimicked the heavens, rotating spheres with planets and moons whirling in tiny arcs. These devices weren't just tools, they were philosophical statements. They said, the universe has order, we can understand it. And that was revolutionary. Still, the romance of the sky never faded. Even as the Greeks drew circles and plotted trajectories, they kept naming constellations after myths. To them, Orion wasn't just a set of coordinates. It was a tragic hunter immortalized among the stars. Cassiopeia wasn't a pattern of dots. It was a vain queen chained to the heavens as punishment. It's poetic, isn't it? For every bit of geometry, there was a story, and those stories kept the cosmos human. They bridged math and meaning. The Romans, for their part, didn't innovate much in pure astronomy, but they did something just as important. They spread the knowledge. As their empire expanded, they carried Greek astronomical texts across continents. Observatories popped up in new corners of the world. Sundials adorned cities from Gaul to Syria, and calendars were standardized across provinces. For the first time, people across vast distances were living by roughly the same sky schedule. The cosmos had gone imperial. Yet, as impressive as all this was, there was still something uneasy under the surface. For all their measurements and models, ancient astronomers were stuck in a loop, literally. Every system assumed circular motion because perfection, they believed, required it. But the planets kept betraying them, drifting slightly off script, refusing to stay neat and tidy. It was as if the heavens were mocking human certainty. The more they tried to force cosmic order into perfect circles, the more reality insisted on being slightly messy. And that tension between beauty and accuracy would eventually break astronomy wide open. But we're not there yet. For now, imagine a night on the coast of Alexandria. The sea is black glass, the stars burn cold and clear, a scholar stands on a terrace with a bronze armillary sphere measuring angles between constellations. He dips his quill into ink, records the numbers, and wonders, if everything in the universe moves in circles, why does it sometimes feel like nothing ever lines up quite right? The answers to that question wouldn't come for centuries. But in those quiet hours, between the turning of the stars and the scratching of ink on papyrus, humanity was already inching closer to the truth. One observation, one mistake, one revelation at a time. As the Roman Empire began to creak under its own weight, something else started shifting, knowledge itself. The old centers of learning, Athens, Alexandria, Babylon, faded into silence or flame, and the heavens for a while went quiet. Libraries burned, scrolls were lost, and centuries of careful observation vanished in smoke. The story of the stars didn't end, though, it just moved house. Astronomy's next great chapter was about to unfold in places that Rome barely understood, under skies it never conquered. When the so-called Dark Ages settled over Europe, the light of astronomy didn't go out, it just moved east. In Persia, in India, in the rising cities of the Islamic world, ancient Greek and Babylonian works found new readers, translators, and challengers. Baghdad in the 9th century was the new Alexandria. Inside its Beit al-Hikmah, the House of Wisdom, scholars worked under oil lamps, translating Aristotle, Ptolemy, and Plato into Arabic. They didn't just copy the old masters, they tested them, refined them, and occasionally called them out for being wrong. This was where science put its armor back on. Imagine standing on a rooftop observatory in Baghdad, the night stretching endless and perfect. Below, the Tigris shimmered. Above, the Milky Way carved a white river across the sky. Astronomers like Al-Farghani, Al-Bathani, and later Ibn al-Haytham watched the heavens with instruments so precise that their measurements would still hold up centuries later. Al-Battani, for example, recalculated the length of the solar year with an error margin smaller than Ptolemy's, and he did it with nothing more than a sextant, patience, and clear skies. But the real revolution was philosophical. Islamic scholars began to see the universe as a divine design, yes, but one that could be understood through reason. Observation wasn't impiety, it was worship. The Quran itself urged reflection on the stars as signs of God's order. So, studying the cosmos became both a scientific and spiritual pursuit. Astronomy wasn't about predicting omens anymore. It was about unveiling divine architecture. And that subtle shift changed everything. Then came the building boom. Observatories sprouted across the Islamic world like stone telescopes. In Naraga, in Persia, Nasir al-Din al-Tusi designed one so advanced that it housed not just astronomers, but entire libraries of star charts and mathematical tables. He proposed a new geometric model. The Tusi couple, to explain planetary motion more accurately than Ptolemy ever could. His idea? That circular motion could produce linear movement when combined, a mathematical hack that centuries later would directly inspire Copernicus. Yes, the so-called father of modern astronomy had a Persian ghostwriter. Meanwhile, in India, astronomers like Aryabhata and Brahmagupta had already been doing their own cosmic calculus. Aryabhata, writing in the 5th century, proposed that Earth rotates on its axis nearly 1,000 years before Europeans would accept it. He calculated the length of the year, the circumference of the planet, even the speed of the moon's orbit, all astonishingly close to modern values. And he did it without a telescope, without metal instruments, without even paper, just the naked eye and genius-level math written on palm leaves. The cross-pollination of ideas between India, Persia, and the Islamic world was like an intellectual constellation all its own. Numbers, formulas, and star tables traveled along trade routes tucked between silks and spices. The Arabic word zij, meaning astronomical table, became the blueprint for a global language of measurement. The zij of al-Sufi, al-Dusi, and ul-Ubaid were passed from scholar to scholar, century to century. When Europe finally woke from its long intellectual nap, these texts were weighted like ancient treasure chests. And speaking of Ulugh, imagine a king who would rather build an observatory than a palace. In 15th century Samarkand, he constructed a giant sextant carved into the ground, large enough to measure the positions of stars with near-perfect precision. His star catalog listed over 1,000 stars, more accurate than any since Ptolemy. Yet his devotion to science earned him little favor in politics. He was assassinated, his observatory abandoned, his work nearly forgotten, until European astronomers rediscovered it centuries later and realized how far ahead he'd been. Back in Europe, the monks of the Middle Ages kept time by bells, not by stars. But even in monasteries, astronomy lingered, hidden in the margins of manuscripts, whispered in the cycles of prayer. The Church needed calendars to calculate Easter, to track feast days, to predict solstices. So, paradoxically, while theology ruled the day, astronomy quietly ruled the clock. Monks became timekeepers, charting the movements of the moon to keep faith synchronized with the heavens. Yet for all its quiet endurance, Europe's astronomy had shrunk compared to what thrived in the East. While Baghdad was recalculating the cosmos, Paris was still debating whether comets were atmospheric vapors or divine warnings. The stars had become a backdrop for sermons rather than a field of study. It would take the spark of rediscovery, the translation of Arabic and Greek texts, back into Latin to light Europe's sky again. So as the last embers of the medieval world began to cool, the stage was being set for a new dawn. The scrolls of Ptolemy, filtered through Arabic and Persian commentaries, made their way into European universities. And one day, a quiet scholar with a sunburned face, sitting in a small room in Poland, would read them and dare to ask the same question the Babylonians, Egyptians, and Greeks had all whispered before him. What if we've got it all backward? That question would change the world. But before we get to the man who asked it, let's pause to appreciate this. For nearly 2,000 years, from the banks of the Nile to the domes of Baghdad, from palm leaf manuscripts to marble sextants, humanity never stopped looking up. Even when empires fell, the stars remained, and someone, somewhere, was still writing them down. The Renaissance, a word that sounds like sunlight breaking through centuries of clouded thought, doesn't it? Europe was waking up from its intellectual slumber, shaking off the dust of dogma, and realizing, perhaps a bit sheepishly, that the rest of the world had been keeping the cosmic lights on in its absence. The parchment trail from Baghdad to Venice had done its job. The old texts dressed in Arabic, translated back into Latin, now whispered dangerous ideas into European ears. Ideas that said, hey, maybe Earth isn't the VIP seat of the universe after all. Enter one Nicolaus Copernicus, the polite, mathematically inclined troublemaker from Poland. He wasn't the first to imagine that the Earth might orbit the Sun. Greek astronomers like Aristarchus of Samos had already floated that thought over 1,000 years earlier. But he was the first to drop the idea into a Europe newly obsessed with logic, geometry, and self-confidence. When he published De Revolutionibus Orbium Coelestium in 1543, he didn't just rearrange planets, he rearranged humanity's sense of importance. Suddenly, the Earth wasn't the center of the cosmos. It was just one of several spinning stones in a vast celestial dance. And for a society that had spent a millennium believing the heavens revolved for its benefit, that was a hard pill to swallow. Copernicus didn't exactly shout his theory from the rooftops. In fact, he whispered it, cautiously, almost apologetically. He knew the implications. His model didn't fit church doctrine or common sense. It made people dizzy to think about the ground beneath them moving. So, for years, his manuscript sat gathering dust while he quietly refined his numbers. Only on his deathbed did he finally allow it to be printed. It's as if he thought, well, if they burn me, I won't feel it anyway. But Copernicus cracked open the vault, and others poured in. Enter Tycho Brahe, a man who, frankly, deserves his own Netflix series. Picture this: a Danish nobleman with a golden nose. Yes, literally, because he lost the real one in a sword duel over who was the better mathematician. Tycho built a private observatory on the island of heaven, complete with towers, murals, and pet moose. There, for decades, he made the most precise naked eye measurements of the stars ever recorded. He didn't buy into Copernicus's heliocentrism entirely. He thought the sun orbited the Earth while the other planets orbited the sun, but his data was gold, and his apprentice, a fiery German named Johannes Kepler, would put that data to revolutionary use. Kepler didn't have Tycho's resources, but he had something arguably more dangerous: relentless curiosity. When Tycho died, Kepler inherited his notes, locked himself in a room, and began crunching numbers like a man possessed. What he discovered overturned 2,000 years of circular thinking, literally. The planets he found didn't move in perfect circles, as Ptolemy and Copernicus had both assumed. They moved in ellipses, stretched out ovals, elegant and imperfect. The heavens weren't clockwork perfection. They were organic, dynamic, a little messy. Kepler's laws of planetary motion transformed astronomy from geometry into physics. But if Kepler gave the planets new parts, Galileo Galilei gave them a voice. In 1609, he pointed a simple telescope, a Dutch invention, barely improved from a spyglass, towards the night sky, and saw what no human eye had ever seen before. The moon wasn't a smooth divine orb. It had craters and mountains. Jupiter had moons of its own, circling it like miniature worlds. Venus changed phases like our own moon, proving it orbited the sun. And the Milky Way? Not a misty band, but a river of countless stars. Every observation Galileo made was another nail in the coffin of Earth's cosmic ego. Of course, the Church didn't take this well. Galileo was dragged before the Inquisition and forced to recant. The story goes that after signing his confession, he muttered, "Eppur si muove," and yet it moves. Whether or not he actually said it doesn't matter. The point is, the telescope had cracked heaven's ceiling. The sky was no longer a realm of gods. It was terrain, mappable, knowable. By the 17th century, the cosmos had become a legitimate scientific playground. Telescopes improved, star charts multiplied, and Europe's intellectuals competed to claim slices of the sky like explorers planting flags on uncharted continents. Astronomy became fashionable. Kings built observatories. Universities funded star maps, and clockmakers perfected timepieces to match celestial precision. The stars weren't just for priests or dreamers anymore. They were for mathematicians, merchants, and anyone who liked a good challenge to authority. But as thrilling as it all was, this new astronomy still had a problem. It described how the planets moved, not why. What invisible force tethered Earth to the sun, the moon to Earth, the planets to their paths? It would take one last genius sitting under an apple tree in England to put that final piece in place. His name? Isaac Newton, and he was about to turn the heavens into math. Before we get there, though, it's worth pausing to appreciate what had just happened. In a few short generations, humanity had gone from gazing at stars painted on divine ceilings to realizing those same stars were sunnant, burning, distant, infinite. The cosmos was no longer a story written for us. It was a mystery we could actually read. And that shift from faith to formula was the real Renaissance revolution, one written not in marble, but in starlight. So there he is, Isaac Newton, quiet, solitary, and probably the last person you'd expect to change how humanity sees the universe. Not a swashbuckling explorer or telescope-wielding showman, but a man who preferred silence, ink, and the company of his own thoughts. Legend has it he's sitting under an apple tree when a fruit drops, and bam, gravity. Of course, that story's been polished smooth by centuries of repetition, but the idea behind it is solid. Newton connected the dots between the falling apple and the moon's orbit and realized something no one had before. The same invisible force pulling the apple to the ground was keeping the moon from flying off into space. That was a mic drop moment in human history. The heavens and the earth weren't separate realms after all. They obeyed the same laws. Newton unified the cosmos with math, turning celestial wonder into measurable motion. His Principia Mathematica was basically the instruction manual for the universe. 3 laws of motion, 1 law of universal gravitation, and a ton of equations that could predict the dance of planets centuries in advance. Suddenly, what had once been divine mystery became predictable geometry. You could now chart the future of Mars or the fall of a cannonball with the same equations. The cosmos, it seemed, was clockwork. But Newton's world wasn't purely mechanical. He believed in a divine watchmaker, God, as the ultimate engineer who built the clock and then let it run. His equations were a way of decoding that craftsmanship. Still, for philosophers and scientists of his era, Newton's discoveries were like finding the cheat codes to reality. The stars no longer needed math. They needed math. With Newton's laws in hand, the 17th and 18th centuries became an age of astronomical ambition. Observatories sprouted across Europe like mushrooms after rain. The Royal Observatory at Greenwich, founded in 1675, became ground zero for the global measurement of time and space. The phrase Greenwich Mean Time would come later, but its roots were here, on a hill overlooking London, where astronomers charted the stars to map the seas. Because, yes, this wasn't just about curiosity anymore. Astronomy had become practical, political, profitable. Sailors needed accurate navigation to cross oceans, and the stars were their GPS. Knowing exactly when and where you were on the planet could mean the difference between reaching India or dying in the middle of the Atlantic. The problem was calculating longitude, something that required knowing the precise time back home. Without it, even the most skilled captain could be off by hundreds of miles. So, astronomers, mathematicians, and inventors raced to solve the longitude problem. The result? The rise of the celestial clock. John Harrison, a self-taught English clockmaker, built a series of marine chronometers so accurate they could keep time on a rolling, storm-tossed ship. His final version, H4, looked like an oversized pocket watch, but was revolutionary. With it, sailors could use star charts and time readings to fix their position anywhere on Earth. Navigation was no longer guesswork. It was a cosmic calculation. The heavens guided empires now. Every trade route, every naval battle, every colonial conquest relied on people staring through telescopes and scribbling equations by candlelight. It's a bit ironic, isn't it? For millennia, humanity looked up at the stars to ask why we're here. By the 18th century, we were looking up to figure out where we were instead. The cosmos had become a map, one drawn not in ink, but in light. And as telescopes grew larger and more precise, the known universe started expanding in terrifying proportions. Then came the Herschels, William and Carolina, a sibling duo who turned stargazing into art and science. William, a German-born musician turned astronomer, built massive telescopes in his backyard and used them to scan the skies night after night. In 1781, he spotted something strange, a tiny disk moving slowly among the stars. It wasn't a star at all. It was a planet, Uranus, the first new planet discovered since ancient times. The universe had just gotten bigger. Meanwhile, Caroline Herschel, often overshadowed in textbooks, was discovering comets, cataloging nebulae, and proving that women could do serious science in a world that barely let them read about it. Her handwritten observations filled volumes, and her careful data helped define modern astronomy. Together, the Herschels showed that the universe wasn't static. It was layered, textured, alive with unseen motion. By the time the 18th century gave way to the 19th, the stars had become numbers in tables, dots on charts, and coordinates on maps. Humanity had learned to measure the cosmos, to quantify it, to control its data. But something was lost, the mystery, the poetry. The same heavens that once inspired myths of gods and monsters were now lines in a ledger of light. Yet the curiosity didn't die, it just changed shape. We'd stopped worshiping the stars, but we hadn't stopped chasing them, because as telescopes peered deeper and deeper into the darkness, a new question began to whisper at the edge of every discovery. If we can measure the heavens, can we ever truly reach them? That question would drive the next era, an age not of stargazers, but of dreamers who wanted to touch the sky itself. The 19th century was when humanity decided that staring up wasn't enough anymore. We'd mapped the heavens, clocked their motions, and catalogued their lights, but there was a gnawing hunger for more, to see further, sharper, deeper, to turn those glittering specks into something tangible. Astronomy was about to get industrial. The age of brass, steel, and steam was also the age of bigger, heavier, and far more dangerous telescopes. Observatories rose like cathedrals of iron and glass. In Ireland, the Leviathan of Parsonstown, the largest telescope on Earth at the time, was built by William Parsons, the 3rd Earl of Ross. Imagine it, a 1.8-meter wide mirror mounted inside a colossal metal tube, swinging between stone walls in the damp Irish air. When Parsons aimed it skyward in the 1840s, he saw something that no one had clearly seen before, a spiral shape, a ghostly swirl of light. He called it a spiral nebula. Little did he know he was staring straight into another galaxy. But that realization would come much, much later. Meanwhile, the stars were no longer just dots of light. They were subjects for analysis. Enter spectroscopy, the brilliant idea that starlight, when passed through a prism, could reveal its chemical makeup. Think about that for a second. Humans had gone from carving calendars on bones to reading the elemental recipes of stars trillions of kilometers away. Astronomers like Joseph Fraunhofer and Gustav Kirchhoff discovered that every element left a distinct fingerprint in light. Hydrogen, sodium, iron, they all etched their signatures in the rainbow. Suddenly, the universe was a chemistry set, and the stars were burning laboratories. Then there were the women who turned that light into meaning. In Harvard, a group of women astronomers, known later, somewhat patronizingly, as the Harvard computers analyzed glass plates filled with photographic star spectra. Among them was Annie Jump Cannon, who classified over 350,000 stars and created the system we still use today. O, B, A, F, G, K, M. And yes, that's the sequence behind every astronomy mnemonic you've ever heard. O, be a fine girl, guy, kiss me. Cannon and her colleagues turned cosmic chaos into organized data while working for a fraction of what their male counterparts earned. Without them, modern astrophysics would still be fumbling in the dark. Photography itself transformed astronomy. Gone were the days of sketching faint smudges by hand while shivering in the cold. With long-exposure cameras attached to telescopes, astronomers could collect light for hours, capturing details invisible to the human eye. Nebulae bloomed on glass like cosmic flames, and star clusters that once looked like mist revealed themselves as swarms of suns. The night sky wasn't static anymore. It was alive, and we finally had the tools to prove it. By the late 1800s, observatories were popping up on mountaintops, far from the smoky glow of cities. Yerkes Observatory in the U.S. boasted the world's largest refracting telescope, while others, like Mount Wilson in California, took things further with massive reflecting mirrors. Telescopes grew so large they needed entire teams to move them, gears the size of wagon wheels, and domes that groaned and clicked as they rotated through the night. It was engineering theater, and the universe was the stage. But even as we were collecting data, something philosophical was shifting. For centuries, astronomy had been a study of where things were. Now it was becoming a study of what they were, and perhaps how they began. The ancient question, "What are the stars?" was finally answerable. They weren't holes in a celestial dome, or lanterns hung by gods, or eternal fires. They were suns, immense boiling spheres of hydrogen and helium, burning through fusion at unimaginable scales. And if that didn't make you feel small enough, astronomers soon realized those suns weren't alone. The Milky Way, once thought to be the entire universe, was suddenly crowded. The sky was full of those spiral nebulae like the one the Earl of Ross had seen. Some astronomers argued they were gas clouds within our galaxy. Others, more daring, suggested they might be island universes, entire galaxies far beyond our own. The debate split the scientific world like a cosmic fault line. No one could prove it yet. And through all this, a quiet revolution was brewing in mathematics and physics. A young clerk in a Swiss patent office was thinking about time, space, and light in ways that made everyone else look old-fashioned. His name was Albert Einstein, and while he didn't own a telescope or an observatory, his equations would soon do what centuries of stargazing couldn't: rewrite the very fabric of the cosmos. But before Einstein's relativity bent the universe, the astronomers of the 19th century had already given us something profound: the realization that we are not separate from the stars. The same elements we read in their light, carbon, oxygen, iron, exist in our bones and blood. We are literally made of the same stuff as the cosmos we measure. For the first time in history, the divide between heaven and earth was gone. We weren't observers anymore. We were participants. And yet, as the 20th century loomed, a new kind of question began to echo among the domes and laboratories. If we're made of the stars, where did they come from? What set the whole cosmic story in motion? The answer would come not from myth or poetry this time, but from explosions, equations, and the faint whispers of light left over from the universe's birth. The dawn of the 20th century cracked open the sky in ways that even Newton couldn't have predicted. The telescope had already shown us stars beyond counting, but the question that haunted every astronomer was this: how far did it all go? The cosmos had always felt infinite, but no one knew. That was about to change, and not gently. This was the century that would take humanity from a cozy, earth-centered universe to one so vast it could crush your sense of scale in a heartbeat. First came Einstein, the soft-spoken disruptor with the wild hair and a brain wired for paradox. In 1905, while most of Europe still measured time by the chime of clock towers, he proposed that time itself could stretch and warp. Space wasn't a rigid backdrop, but a flexible fabric, curved by gravity and mass. The bigger the object, the deeper the dent it made in space-time. The planets didn't orbit because of invisible strings or mystical forces. They were simply following the curves in the cosmic mattress made by the sun. It was elegant, terrifying, and absolutely revolutionary. Einstein's general theory of relativity, published a decade later in 1915, rewrote the universe. Light could bend, time could slow, gravity wasn't a pole, it was geometry. And if the universe was a flexible fabric, it meant something extraordinary. It could stretch. It could move. Maybe it wasn't static at all. But Einstein himself didn't like that idea. He added a cosmological constant to keep his equations tidy, forcing the universe to stay still. Little did he know that mathematical patch job would turn out to be one of the biggest scientific oops moments in history. While Einstein was reshaping physics with math, a new breed of astronomer was reshaping it with glass and metal. On a California mountain called Mount Wilson, a man named Edwin Hubble was using the world's largest telescope, 2.5 meters across, to peer into those faint spiral smudges first seen by the Earl of Rosse. Hubble's photographs revealed something staggering. Those spirals weren't within our Milky Way. They were other galaxies, millions of light years away. The universe had just exploded in size. And it didn't stop there. By measuring the light from those galaxies, Hubble noticed something eerie. Their light was redshifted, stretched toward the red end of the spectrum. The farther away a galaxy was, the more its light stretched. The only explanation? The galaxies were moving away from us. All of them. The entire universe was expanding. Suddenly, Einstein's cosmological constant looked like a cosmic blunder, and the universe was no longer eternal and unchanging. It had a beginning. That beginning would later be called the Big Bang. The idea was proposed by a Belgian priest and physicist named Georges Lemaitre in the 1920s, who suggested that the universe began as a primeval atom, a single dense point that exploded outward. The scientific world scoffed at first. Even Einstein wasn't convinced. He famously told Lemaitre, "Your calculations are correct, but your physics is abominable." Yet decades later, when radio telescopes picked up the faint hiss of cosmic background radiation, the leftover glow from that primordial explosion, Lemaitre's abominable idea became the cornerstone of modern cosmology. But let's not get ahead of ourselves. Back on Earth, the early 20th century was buzzing with new tools and technologies that turned stargazing into something unrecognizable. Spectrographs, photographic plates, and later radio antennas allowed astronomers to capture the universe in wavelengths the human eye could never see. Suddenly, the cosmos wasn't just a picture. It was a symphony of invisible light, from radio waves to gamma rays, each frequency revealing a new layer of reality. And with all that data came an even bigger revelation. The stars weren't eternal. They lived, they burned, and they died. Cecilia Payne, a young British astronomer working at Harvard in the 1920s, cracked the code of stellar composition. By analyzing starlight, she discovered that stars were made mostly of hydrogen and helium, not iron or rock or fire, as had been assumed for centuries. The universe, she realized, was simpler and more unified than anyone had dared imagine. Her PhD thesis, quietly revolutionary, became one of the most important in the history of astronomy. Soon after, physicists began piecing together the life cycles of stars. Nuclear fusion became the new celestial gospel. In the hearts of stars, hydrogen fused into helium, releasing the energy that made them shine. Bigger stars fused heavier elements, carbon, oxygen, iron, until they collapsed in spectacular explosions called supernovae. scattering those elements into space. The same stardust that once formed planets, oceans, and life itself came from those ancient cosmic depths. Carl Sagan would later put it simply, "We are made of star stuff." But that poetic truth was first uncovered in dusty observatories by people staring at faint lines on glass plates. By mid-century, astronomy had evolved from a gentleman's hobby into a high-tech global enterprise. The Cold War pushed the boundaries of rocketry, radar, and computing, all tools that would soon be turned skyward. Giant radio dishes listened to the hum of the cosmos. Infrared sensors saw through dust clouds. X-ray telescopes caught the violent tantrums of black holes and neutron stars. The universe wasn't serene anymore. It was chaotic, violent, and alive with motion. And through all of this, one profound realization settled over humanity. The universe wasn't built for us. It wasn't even aware of us. It was vast, indifferent, and ancient beyond measure. And yet, somehow, here we were, tiny beings with fragile eyes and restless minds, able to understand it. That paradox, the insignificance of our place versus the miracle of our comprehension, became the beating heart of modern astronomy. The night sky was no longer just a map. It was a story of birth, decay, and rebirth, written in fire and light. But by the middle of the 20th century, astronomers began asking a question that reached beyond even that grand narrative. If stars could form, burn, and die, what about worlds? Could there be others like ours, orbiting distant suns? And if there were, who or what might be looking back at us? By the 1950s, the telescope was no longer just a long tube of glass and brass. It was a time machine. With each new improvement, astronomers were staring further and further into the past. Every photon captured on film was a whisper from billions of years ago. Yet, as humans looked deeper into space, the focus began to shift closer to home, not toward stars or galaxies, but toward planets. For most of human history, planets had meant only the ones visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. Then came Uranus and Neptune, discovered by telescope, like prizes hidden in the cosmic shadows. But even then, the idea that other stars might have planets of their own was little more than a romantic notion, whispered in science fiction stories and speculative papers. After all, no one had seen one, and astronomy by now demanded proof. The first half of the 20th century brought the machines that could turn dreams into data. Spectroscopy, breaking starlight into its component colors, became the astronomer's scalpel. Through it, they could detect subtle wobbles, changes in light, and minute shifts that hinted at gravitational tugs, signs that a star might have a hidden companion. But these tools were crude compared to what was coming. Then came space. When the Soviet Union launched Sputnik 1 in 1957, the tiny beeping metal ball wasn't just the first man-made object in orbit. It was humanity's announcement. that we were no longer bound to the ground. Within a few years, telescopes would follow it beyond the atmosphere, escaping the distortions of Earth's air. The Hubble Space Telescope was still decades away, but the dream was already forming: to see the universe unfiltered. The space race didn't just put humans on the moon. It cracked open an entirely new branch of astronomy. Orbiting observatories began peering at the cosmos in X-rays, ultraviolet and infrared, wavelengths impossible to detect from the ground. The universe suddenly looked different, hotter, brighter, stranger. Quasars, pulsars, and black holes emerged from the darkness like cosmic beasts. And yet, even as humanity reached for the stars, we began obsessing over one question: were we alone? It's almost funny how predictable that question became. The more we learned about the vastness of space, the harder it was to believe we were the only ones in it. In 1961, an astronomer named Frank Drake created a formula, the Drake equation, to estimate the number of communicative civilizations in the galaxy. It wasn't meant to give a real number, just a framework for thinking. Plug in the rate of star formation, the fraction with planets, the number of planets that could support life, and so on. Depending on your optimism, the answer ranged from "we're alone" to "they're everywhere." And then, in 1964, a faint microwave hum was accidentally discovered by two radio engineers, Arno Penzias and Robert Wilson. They thought it was pigeon droppings in their antenna. It wasn't. It was the afterglow of creation, the cosmic microwave background, the echo of the Big Bang itself. The universe wasn't just expanding, it had a birth certificate. Suddenly, the Big Bang wasn't a theory anymore. It was a fact written across the entire sky. This was the age when cosmology went from philosophical to empirical. The universe had a beginning, a measurable age, and a structure. It had filaments, voids, clusters, and dark matter, an invisible scaffolding holding galaxies together like a web spun by an unseen hand. It was beautiful and eerie, and it raised a new kind of question. If we could measure the birth of everything, could we predict its end? But before anyone could answer that, the search for other worlds took a leap forward, one that would take centuries of dreaming and turn it into data. In 1995, Swiss astronomers Michel Mayer and Didier Queloz detected the first confirmed planet orbiting another star, 51 Pegasi b. It was a gas giant orbiting scorchingly close to its sun, completing a year in just 4 days. It wasn't the Earth 2.0's humanity had hoped for, but it was proof. The universe was littered with planets. Soon new methods, transit detection, radial velocity, direct imaging, revealed hundreds, then thousands of exoplanets. Some baked in eternal daylight, others orbited twin suns. Some were rocky, some were watery. A few even sat in the so-called habitable zone, where liquid water might exist, and the pace only accelerated. By the 21st century, telescopes like Kepler and TESS were scanning the sky with algorithms instead of eyes, detecting dips in starlight caused by orbiting planets. The numbers were staggering. It wasn't a question of if there were other Earths. It was how many. Astronomers began to realize that planets were the rule, not the exception. Practically every star had its own family. But the universe, as always, refused to make things simple. For every discovery, a mystery deepened. Dark energy, the invisible force driving cosmic expansion faster and faster, remained unexplained. Galaxies moved as if haunted by unseen mass, dark matter, making up most of the universe, yet detectable only through gravity. We could map its fingerprints, but not its face. Still, we kept looking. We built telescopes that could fold like origami and launch into orbit. We pointed arrays of radio dishes across deserts and mountains, forming synthetic eyes the size of Earth. We even began planning for the next great observatory, the James Webb Space Telescope, a machine capable of looking back 13 billion years to the first galaxies that ever formed. And as our instruments grew sharper, so did our questions. Were we just observers in this cosmic story, or participants? Could life, given the right conditions, be as common as starlight? Could the same chemistry that gave rise to oceans and consciousness on Earth be quietly bubbling on a moon of Jupiter or in a cloud around a red dwarf star? By the dawn of the modern era, humanity stood on the edge of an astonishing realization. We were no longer just in the universe. We were beginning to understand it. The cosmos was no longer a ceiling. It was a mirror, showing us what we were made of and what we might yet become. But that realization carried a darker edge. The more we grasped about the universe's vastness, the smaller we felt. And in that smallness, another question began to echo, one as old as curiosity itself, but sharper than ever before. If we are made of the same dust as the stars, then why do we still feel so alone in the dark? Aloneness in the cosmos. What a strange paradox. On one hand, we can detect planets hundreds of light years away with the precision of a clockmaker. On the other, we can't name a single neighbor who's waved back across the void. The silence, that cosmic hush, became almost unbearable to some scientists. So unbearable, in fact, that they decided to start shouting into the dock. That's how SETI was born, the search for extraterrestrial intelligence. Starting in the 1960s, radio astronomers like Frank Drake began turning giant dishes toward the stars, hoping to catch an artificial signal. Something structured, something intentional. In 1974, they even sent one out from the Arecibo Observatory in Puerto Rico. Humanity broadcast a radio message into space, encoded with information about who we are, where we live, and what we look like, right down to the structure of our DNA. The problem? The target star, M13, is 25,000 light years away. Even if someone's listening, the reply won't arrive until the year 27,000. Patience, it seems, is mandatory for cosmic conversation. While SETI pointed its ears to the heavens, planetary scientists began exploring closer mysteries, our own solar system. The robotic age of exploration unfolded like a series of postcards from the planets. The Mariner missions flew past Venus and Mars. Pioneer and Voyager went further, crossing the outer planets and eventually escaping the sun's gravitational reach altogether. Each carried messages too, golden records with greetings, music, and sounds of Earth. Carl Sagan helped design them, calling them bottles cast into the cosmic ocean. They're still drifting out there, silent ambassadors of a species that dared to look up. Back home, astronomers weren't just collecting data. They were building cosmic time machines of unimaginable power. The Hubble Space Telescope, launched in 1990, orbiting Earth like a giant unblinking eye. At first, it was a disaster. A tiny flaw in its mirror made its images blurry, and the media had a field day. Billions of dollars, and the thing couldn't focus. But then NASA sent astronauts on a repair mission, and the first sharp images came back. Galaxies by the thousands, stretching across space like spilled jewels. It wasn't just beautiful, it was humbling. For the first time, humans could see how vast the universe truly was. Each deep field photograph from Hubble was like a window into eternity. A patch of sky no bigger than a grain of sand held thousands of galaxies, each with billions of stars. The idea of cosmic solitude started to seem less credible by the day. How could all that be empty? Surely, somewhere in that ocean, something else was looking back. Yet, even as the universe expanded before our eyes, so did our sense of fragility. We learned that the same forces that forged stars and galaxies could snuff them out. Supernovae, those stellar death throes, were not just spectacular explosions. They were factories for everything we're made of. The iron in your blood, the calcium in your bones, the oxygen in your lungs, they were born in the heart of dying stars. We are, quite literally, stardust that learned to think. It sounds poetic, but it's also brutally factual. Every element heavier than hydrogen owes its existence to cosmic violence. Beauty born of destruction. And speaking of destruction, astronomers started realizing just how delicate Earth's position was. Cosmic catastrophes weren't just science fiction, they were routine. Meteor impacts, gamma-ray bursts, solar flares, the universe had plenty of ways to reset the clock. The same cosmos that nurtured life could, at any moment, erase it without notice. When you start studying the stars long enough, you realize they don't care about us at all. That's both terrifying and liberating. But humans don't stop at terror. We build meaning out of it. And as space telescopes grew more advanced, we turned our gaze to atmospheres. Not just ours, but those of distant worlds. Using light filters and spectrograms, scientists could now detect the faint chemical fingerprints of oxygen, water vapor, even methane on alien planets. It was like smelling the faint aroma of life on the cosmic breeze. Nothing confirmed yet, no alien civilizations waving hello, but tantalizing clues that life, or at least habitability, might be common after all. The irony, of course, is that as we searched for life elsewhere, we also began to understand how extraordinary Earth really is. It's easy to romanticize Mars or Europa or some distant exoplanet, but so far none have the perfect mix of sunlight, atmosphere, and stability that our pale blue dot enjoys. And that dot is fragile. One small shift in orbit, one massive volcanic eruption, one nuclear misstep, and it could all go dark. Looking out at the stars began to make people look inward too. Astronomers became philosophers by accident. The deeper they looked, the more they realized that understanding the universe wasn't just about finding our place in it, it was about protecting the one home we know works. Meanwhile, ground-based telescopes were fighting back against their orbital cousins. Adaptive optics, giant segmented mirrors, and laser-guided corrections allowed Earth-bound observatories to rival space telescopes. The European Southern Observatory's Very Large Telescope, yes, that's literally its name, could produce images sharp enough to study planets forming in dust clouds light years away. The race wasn't just about seeing further. It was about seeing deeper. And then came a new kind of astronomy altogether. Instead of light, we began detecting ripples in spacetime. In 2015, the LIGO Observatory recorded the first gravitational waves, tiny distortions in the fabric of the universe caused by two black holes colliding. Einstein had predicted them a century earlier, But even he doubted we'd ever detect them, and yet there they were, a faint, fleeting vibration that confirmed one of the most elegant ideas in physics. The universe wasn't silent. It was ringing softly with the echoes of creation and collapse. By the 21st century, our celestial mapping wasn't just about stone tablets or papyrus scrolls. It was data streams, digital simulations, and orbiting observatories that could turn starlight into history. Humanity had gone from scratching patterns on rocks to reading the cosmic DNA of galaxies. And still, despite all that progress, we found ourselves circling back to the same ancient questions the Egyptians, the Babylonians, and the Maya once asked. Where did we come from? Why are we here? What lies beyond the horizon? Maybe that's the real constant across time, the need to map meaning onto the stars. The tools have changed, sure. The questions haven't. It's strange, isn't it? Thousands of years ago, a Babylonian priest, carving marks on clay tablets, looked up at the same night sky as a modern astronomer operating a telescope worth billions. The tools are different, the language is different, but the impulse, the raw, almost desperate need to understand the heavens, remains identical. Somewhere deep in our wiring, curiosity about the cosmos is stitched next to fear of the dark. Because, let's be honest, space is terrifying. It's vast, cold, silent, and indifferent. Yet somehow we can't look away. By the 2020s, that curiosity had become industrialized. Telescopes no longer looked like single tubes pointed at the sky. They looked like entire facilities. The Atacama Desert in Chile, one of the driest places on Earth, had become a cathedral for astronomy. Up there, the air is so dry, so thin, and so still that it feels like the sky itself is sitting closer to the ground. Gigantic mirrors, polished to nanometer precision, reflect starlight that's traveled for billions of years, and computer algorithms sharpen every photon into meaning. The extremely large telescope, again, that's the actual name, was designed with a mirror 40 meters wide. If ancient stargazers worshipped the sky, modern ones engineer it. And still, for all our progress, we can't shake the mystery. We've mapped the visible universe. We've measured the cosmic microwave background, seen galaxies at the edge of time, and calculated that the universe is about 13.8 billion years old. Yet, the shocking truth is that we still don't know what most of it is. About 68% of everything out there is dark energy, an invisible force making the universe expand faster and faster. Another 27% is dark matter, mass we can't see, but whose gravity bends light and sculpts galaxies. That leaves just 5% for everything we actually understand. Stars, planets, you, me, coffee, cat videos, everything. In cosmic terms, we're studying the foam on top of an invisible ocean. The more we learned, the less we seemed to know. Einstein's equations worked, but they didn't fit neatly with quantum mechanics, the theory governing the microscopic world. Space-time curved beautifully in relativity, but quantum physics whispered that it was actually a jittering, fluctuating chaos beneath the surface. The universe was a paradox, and we were the creatures trying to decode it with monkey brains and silicon chips. But we didn't stop. The next frontier wasn't just looking at space. It was touching it, living in it. The International Space Station became a kind of orbital village where astronauts from rival nations worked side by side, testing the limits of human endurance. Private companies joined the party too, promising commercial flights, lunar bases, even Martian colonies. Some saw it as humanity's destiny. Others called it hubris. After all, if we haven't learned to take care of one planet, what makes us think we can handle two? Meanwhile, new instruments began mapping the sky in ways our ancestors could never imagine. Radio telescopes like ALMA captured the coldest regions of the universe, where stars are born. The Event Horizon Telescope, a network of observatories spanning the globe, managed to do the unthinkable: take a picture of a black hole. Not an artist's impression, not a simulation, an actual photograph of light being swallowed by gravity itself. The image went viral, of course. A glowing orange ring against a black void, like the eye of some ancient cosmic god finally staring back. Humanity, after centuries of speculation, had finally seen the unseeable. But what's remarkable is how every new discovery only brings us closer to the oldest questions. The Greeks called the universe cosmos, meaning order, because they believed it was governed by reason, not chaos. Now we've learned that chaos is part of that order, that randomness and entropy are built into the system. Stars live and die, galaxies collide, entire civilizations could rise and vanish without the universe noticing. And yet, somehow, in the midst of that cosmic indifference, life appeared, conscious life, life that builds telescopes, sends robots to other planets, and asks why. Maybe that's the point. Maybe the purpose of mapping the cosmos was never just to understand it, but to understand ourselves. Every ancient stone circle, every papyrus map, every satellite orbiting the Earth, they're all reflections of the same human urge to make sense of existence. We are pattern-seeking creatures staring into randomness and trying to find meaning. And what we've learned after millennia of gazing upward is humbling. The cosmos doesn't revolve around us. It never did. We're not the center, we're a consequence. But we're also the only known observers in this infinite experiment, the universe becoming aware of itself for a brief moment in time. That thought alone is staggering. Out of 13.8 billion years of chaos and chemistry, consciousness appeared, and it's us. Still, you can't help but wonder, if the universe can produce us, could it have produced others? Not little green men in flying saucers, but intelligent beings looking up at their own night sky, wondering the same thing. Maybe somewhere out there, another civilization has its own Hubble, its own mathematicians scribbling equations on the nature of time, its own philosophers arguing about purpose. And maybe, just maybe, they're listening to. For now, though, we listen to the silence. We send signals. We launch telescopes. We search for faint wobbles in starlight. And in that silence, we find a strange comfort. Because silence isn't the same as emptiness. It's possibility. The same kind of possibility that drove our ancestors to scratch constellations on stone and chart the heavens on fragile papyrus. And as we look toward the future, one thing is certain. Humanity's fascination with the stars isn't fading, it's accelerating. The universe may be expanding, but so is our curiosity. And that, perhaps, is the most human thing of all. By now, the story of humanity's relationship with the stars had stretched from bone calendars and clay tablets to orbiting telescopes and quantum sensors. Yet even with all that progress, the core of astronomy remained startlingly familiar. It was still about looking up and trying to make sense of the patterns. The only difference was the scale. What once fit on papyrus now sprawled across data centers. What once took a lifetime to observe could now be captured in milliseconds. But the heart of it, the wonder, the confusion, the audacity, was the same. In the 21st century, the maps of the cosmos became so detailed they started to feel like simulations of reality itself. Projects like Gaia and Sloan Digital Sky Survey began cataloging millions of stars and galaxies in 3 dimensions, creating the most comprehensive cosmic atlas ever made. You could zoom out from the solar system, glide past neighboring stars, watch the Milky Way twist like a shimmering spiral, then keep going until the galaxy itself was just one dot in a web of billions. It was breathtaking, but also existentially crushing. It's hard to feel important when you can literally see your insignificance rendered in high resolution. Still, knowledge has its own kind of comfort. When you can chart the heavens, predict eclipses, and trace cosmic origins, you start realizing that chaos isn't random, it's just complicated. Every orbit, every collision, every star birth follows laws so precise that the universe starts to resemble one giant, intricate clock. Not the kind you wind by hand, but one made that the gravity, light, and time. And that idea that the cosmos could be understood was maybe the greatest revolution of all. The ancient Egyptians had built temples aligned to the rising sun. The Maya had timed their rituals to Venus. Now physicists were using atomic clocks so precise that they could detect the difference in time between your feet and your head. The universe had gone from being read through myth to being measured through math. It was no longer divine mystery, yet was data. Yet somehow that didn't make it less magical. If anything, it made the magic feel earned. But for all our precision, the universe still refused to play fair. Take black holes, for example. Einstein's equations predicted them, but he didn't believe they could exist. The idea that gravity could be so intense that not even light could escape, it sounded absurd. And yet, the evidence piled up until absurdity became reality. Black holes became the ultimate punchline of cosmic irony. Regions of space where time stops, physics breaks, and matter gets stretched into oblivion. We can describe them mathematically, but conceptually they still mock us. They're cosmic do not enter science, the places where knowledge hits its limit. Then there's the question of time itself. Ancient astronomers used it to measure cycles, sunrise, moonrise, solstices. But modern physics turned time into something elastic, relative, and deeply weird. Clocks tick slower near strong gravity. The faster you move, the more time bends. In a very literal sense, time flows differently for everyone. Somewhere, Einstein is probably smirking. And the more we've learned about time, the more it seems like another kind of map, one we're still learning to read. But if the cosmos has taught us anything, it's that limits are invitations. Whenever humanity has hit a wall, we've turned it into a doorway. The discovery of quantum mechanics was supposed to end classical certainty. It birthed an entire new field of technology. The realization that light had a speed limit didn't stop exploration. It gave us relativity. Even chaos, it turns out, can be productive. Meanwhile, the tools for stargazing continued to evolve. Drones, satellites, machine learning algorithms, all of them became part of the new celestial toolkit. Astronomers were no longer solitary figures staring through eyepieces. They were data analysts, coders, architects of simulation universes. The night sky wasn't just something you looked at, it was something you could compute. Entire galaxies could be recreated in virtual models, tested and rewound like cosmic experiments. Ancient observers traced the heavens on papyrus. Modern ones ran them through code. Both, in their own ways, were trying to read the mind of creation. And that's when the lines between cosmology and philosophy blurred again. Because the deeper we looked, the more we realized that reality itself might not be as solid as it seems. Quantum physics told us that particles could exist in multiple states at once until observed. Some scientists even began to wonder if the universe itself functioned like a grand simulation, a self-generating reality built on information rather than matter. It sounds like science fiction, but then again, so did the idea of curved space or time travel 100 years ago. Even the concept of a map began to evolve. In ancient times, a star map was drawn in pigment or carved in stone. Now, a celestial map was a database of petabytes, a living thing that updated with every observation. The map wasn't just representing the cosmos, it was becoming part of it. Every observation we made changed our understanding, and every new understanding changed how we observed. It was a feedback loop of discovery. Humanity and the universe were locked in a strange conversation, each revealing the other bit by bit. Still, amid all the math, telescopes, and computer simulations, the same primal awe lingered. Step outside on a clear night, away from city lights, and it's still there. The overwhelming, humbling vastness, the same view that guided farmers, terrified priests, and dreamers for millennia. You don't need a supercomputer to feel small under infinity. You just need eyes and a moment of silence. Because maybe, in the end, that's what astronomy has always been. A mirror we aim at the sky and find ourselves reflected in it. The ancient sky watchers built monuments of stone. We build observatories of steel and silicon. But the impulse is identical: to reach beyond the limits of what we can touch and find meaning in the unreachable. And no matter how advanced our technology gets, that impulse isn't going anywhere. It's coded into our species like gravity itself. If you strip away all the machinery, all the algorithms, and the billion-dollar observatories, what's left at the core of astronomy isn't metal or math. It's emotion, wonder, fear, curiosity. That quiet ache that pulls your eyes upward when the world feels too small. Humans have been staring into the same void since the first spark of consciousness flickered in a cave somewhere. The tools changed, the names changed, but the stare, that hasn't gone anywhere. In a way, astronomy has always been our therapy. When you think about it, ancient star charts weren't just scientific tools. They were comfort blankets. Maps of the sky gave structure to a world that was unpredictable and often cruel. If you could track the movements of the stars, maybe you could predict when the floods would come, when to plant crops, when the gods might smile again. Even now, the impulse is the same. We might have satellites instead of stone calendars, but we're still trying to tame uncertainty with patterns. The cosmos hasn't changed. We just upgraded our anxiety management. And then there's the deeper pole, the one we rarely talk about. Looking at the stars reminds us how brief we are. Every ancient skywatcher must have felt it, that unsettling awareness that we're tiny, temporary, and that the heavens will outlast everything we build. The Babylonians might have explained it as divine will, the Greeks as cosmic order, and we call it astrophysics. But underneath it all, it's the same humbling realization: we're here for a blink. That's not depressing, it's clarifying. You can almost feel time itself stretching over you when you realize that the light hitting your eyes left its source before your species even existed. By the time humanity started mapping the stars with machines instead of myths, we began uncovering another kind of map entirely, one etched not in stone or papyrus, but inside us. Because, as it turns out, the atoms in our bodies, the calcium in our bones, the carbon in ourselves, they were all forged in ancient stars. When those stars exploded, their remains drifted through space, eventually coalescing into new systems, new planets, and eventually, us. It's not poetic metaphor, it's chemistry. You are literally recycled starlight. The same matter that once glowed in some forgotten constellation is now holding a phone, watching a screen, listening to the story of its own origin. That's not just science. That's myth reborn through math. But there's a catch to knowing this much. The more precise our cosmic maps get, the more we realize how fragile our coordinates are. Earth isn't just a planet, it's a coincidence. Right temperature, right distance, right atmosphere, right magnetic field. If any of those dials were off by even a fraction, life as we know it wouldn't exist. Some call it the Goldilocks principle, because we really did end up in the just right zone. Others call it luck. Either way, it's terrifying. The universe isn't built for comfort. It's built for extremes, frozen wastelands, molten hellscapes, radiation storms, and yet somehow in that chaos, there's us. It's like finding a blooming flower in the middle of a supernova. That tension, the coexistence of chaos and life, is what keeps us coming back to the telescope. Because maybe the stars don't care, but we do. Every time we point a lens skyward, it's an act of defiance. We're saying, we see you. We know we're small, but we're watching. That's not just science. That's rebellion against cosmic insignificance. And let's not pretend it's all noble curiosity. There's ego mixed in too. The same impulse that made pharaohs align their pyramids with the heavens now drives billionaires to launch their own rockets. Every age has its own form of cosmic vanity. Ancient kings built monuments to touch the sky. Modern ones build space programs to leave the planet. It's the same gesture, just wrapped in modern branding and better fuel efficiency. Yet despite all the ego, there's something undeniably pure about our pursuit of the stars. For every self-serving space race, there are hundreds of quiet moments of discovery. A graduate student processing a blurry image and realizing they've just seen a galaxy no human has ever seen before. An amateur astronomer in a backyard catching a comet that slipped past NASA's algorithms. The cosmos doesn't care who's watching. It rewards attention. And the more attention we give it, the more it gives back. Modern astronomy has revealed structures so immense they defy imagination. Superclusters of galaxies connected by cosmic filaments stretching across billions of light years. From a distance, it almost looks organic, like the neurons in a brain. Some scientists have even drawn comparisons between the large-scale structure of the universe and the structure of the human mind. It's as if the cosmos and consciousness mirror each other, a fractal pattern of awareness and energy. The universe isn't just something we observe. In a strange way, it's something we participate in. But here's the kicker. For all our progress, all our data, all our telescopes and simulations, we've barely scratched the surface. Our observable universe is finite, about 93 billion light-years across. But beyond that, we have no idea. There could be infinite space, infinite galaxies, infinite versions of reality. Or maybe, beyond that edge, there's nothing at all, just absence, a silence so total it erases even the idea of time. And maybe that's the true limit of mapping the cosmos, realizing that the map will never be finished. Still, humans have never been good at accepting limits. Every time we reach the horizon, we redraw it. The sky once ended at the clouds. Then it ended at the moon. Now it ends somewhere past the edge of what our instruments can detect. Each time we refuse to stop. Maybe it's foolish. Maybe it's glorious. Maybe it's both. But one thing's certain. We were never meant to stay still under the stars. We were meant to chase them. Let's pause and appreciate something weird about us as a species. We've been staring at the sky for roughly 300,000 years, and we still don't get bored. Think about that. Fire, wheels, bronze, empires, they all came and went. But the night sky? It's the one constant in humanity's entire existence. And even though every generation is convinced they're the smartest one, the basic act of looking up and wondering hasn't changed since the first human noticed the stars weren't just random dots, but something meaningful. The funny part is, those early sky watchers didn't have data. No spectral analysis, no parallax measurements, not even glass lenses. They had intuition, rhythm, and ritual. Yet somehow they built mental models of the universe that, while wrong in detail, were profoundly right in spirit. The Egyptians aligned their monuments with Orion's belt. The Maya tracked Venus with precision rivaling early European astronomers. The Chinese catalogued comets and novae centuries before telescopes even existed. They didn't need to know what a light year was to understand that the heavens ran on rules, and rules meant meaning. The real magic of ancient astronomy wasn't the accuracy, it was the worldview it created. The sky wasn't just a ceiling, it was a storybook, a calendar, a clock, and sometimes a moral compass. The stars told you when to plant crops, when to go to war, when the gods were angry. Celestial order meant earthly order. To live in harmony with the heavens was to live in harmony with everything else. It's almost poetic. Before we had science, the stars were our philosophy. But then came a revolution. A man in Poland named Copernicus quietly rearranged the universe with a single dangerous idea: what if Earth isn't the center? It sounds obvious now, but back then it was borderline heresy. To dethrone humanity from the cosmic throne wasn't just a scientific statement, it was a psychological earthquake. For millennia, we'd assumed the universe revolved around us. Suddenly, we were just another planet, circling an ordinary star in an ordinary galaxy in a universe that didn't seem to care. It's funny. Every major leap in astronomy seems to bruise our ego a little more. Galileo pointed his telescope at the heavens and found mountains on the moon and moons around Jupiter. Proof that the cosmos was bigger and more complex than the church wanted to admit. Newton came along and turned gravity into math, showing that celestial motion followed the same rules as falling apples. Einstein then twisted space and time themselves, proving that even the universe's fabric was flexible. Each step pulled us further from the center, until finally we were left standing on a pale blue dot, just one speck among billions. But there's a paradox in all this cosmic humiliation. The more insignificant we seem, the more magnificent our perspective becomes. After all, the universe might not care about us, but we care about it. We're the only creatures, at least as far as we know, who've looked back at the cosmos and tried to understand it. That ability to comprehend, to connect the dots between photons and physics, is what redeems our smallness. We might not be the center, but we are the observers, and that gives us a kind of meaning the stars themselves don't possess. And observation, as it turns out, changes everything. When Edwin Hubble peered through his telescope in the 1920s, he discovered that distant galaxies weren't just sitting still, they were moving away. The universe was expanding. That single discovery reshaped modern cosmology. Suddenly, the cosmos wasn't static. It had a history, a beginning, and possibly an end. The Big Bang Theory emerged, and with it, a new kind of awe, the kind that comes when you realize every atom in existence was once packed into a point smaller than a pinhead. That's when astronomy shifted from gazing to genesis. We weren't just charting the heavens anymore. We were uncovering our own cosmic birth certificate. The elements that make up your body were forged in the cores of ancient stars, scattered by supernovae, and recycled by gravity into new systems. When you take that seriously, you realize that astronomy isn't just about looking outward. It's about looking backward, through layers of time and starlight, until you hit the moment when everything began. And then comes the real existential gut punch. The light we see from distant galaxies is ancient. When you look at the Andromeda Galaxy, you're seeing it as it was 2.5 million years ago. That's before humans even existed. Every time you look up, you're peering into the past, sometimes by billions of years. It's like having a time machine that only looks one way. The stars might seem eternal, but they're more like memories, bright ghosts of what once was. Still, even knowing that, we keep looking, because astronomy isn't really about answers. It's about questions that keep evolving. The ancients asked, "What are those lights in the sky?" We ask, how did those lights become everything? Same wonder, just new vocabulary. And maybe that's the ultimate continuity, curiosity itself. Whether it's a priest on a ziggurat or a physicist at CERN, they're both chasing the same thing, a glimpse behind the curtain of existence. Maybe that's the real secret of astronomy. It's not about finding our place in the universe. It's about making peace with not having one and still finding beauty in the mystery. Because even when you strip away the myths, the math, and the machinery, the sky still does what it's always done. It humbles us. And maybe, just maybe, that humility is the most human thing of all. By the late 20th century, stargazing had gone from a pastime of philosophers to an industrial-scale operation of machines, data, and budgets that could fund small nations. The great observatories of the world, Palomar, Mauna Kea, Paranal, weren't just domes with lenses anymore. They were time machines, peering deeper into space and therefore further into the past than any human eye could. The universe was no longer something you simply looked at. It was something you processed. Petabytes of data, mountains of math, armies of algorithms. The romance of the lone astronomer sketching stars on parchment had given way to a cold, humming glow of servers. But while the tools changed, the hunger didn't. We still wanted to know where we came from, where we're going, and whether we're alone. The difference was, now we could actually start to answer those questions. The Hubble Space Telescope, launched in 1990, changed everything. Hanging in orbit above Earth's atmosphere, it snapped the most detailed photos of the universe ever taken. Entire galaxies, millions of them, appeared in what had once looked like empty darkness. Suddenly, every patch of sky was teeming with ancient light. The universe wasn't vast, it was overcrowded. Hubble's images did more than inspire. They rewrote textbooks. It revealed the birthplaces of stars in vast nebulae, watched galaxies collide, and even helped measure the age of the universe. But maybe its most humbling gift was the Hubble Deep Field, a long exposure of a tiny, empty part of the sky. When the data came back, it showed over 3,000 galaxies, each one a city of stars. Imagine that, a cosmic metropolis hiding in a speck of darkness no bigger than a grain of sand held at arm's length. It was as if the universe had whispered, "You think you've seen it all? Think again." Meanwhile, down on Earth, the astronomers weren't just measuring light, they were decoding it. Every wavelength carried secrets. By splitting starlight into spectra, scientists could read the chemical fingerprints of stars and galaxies. They could tell what something was made of, how fast it was moving, even how old it was. It's like forensic science for the cosmos. And the evidence all pointed to one mind-blowing conclusion. The universe wasn't just expanding, it was accelerating. Enter dark energy, the biggest, weirdest mystery of modern astronomy. Roughly 70% of the universe is made of something invisible, intangible, and completely beyond our current understanding. It's like the cosmos is filled with a silent force, pushing everything apart faster and faster. The rest of the universe? Mostly dark matter, which doesn't emit or absorb light, but makes up the scaffolding of galaxies. Put it all together, and here's the ultimate punchline. Everything we can actually see, stars, planets, people, pizza, is less than 5% of the cosmos. The rest is shadow. And if that doesn't make your jaw drop, think about this. We can detect the afterglow of the Big Bang itself. The cosmic microwave's background, this faint radiation left over from the universe's birth, has been mapped in exquisite detail. It's like an ultrasound of existence, showing the moment when matter, energy, and light first danced into being. It's messy, beautiful, and full of clues about how everything began. That fuzzy pattern in the sky, that's literally the oldest photograph in the universe. But as our vision sharpened, our sense of cosmic loneliness deepened. Because the better we got at observing the universe, the more we realized how tiny and isolated we really are. Yet we couldn't help ourselves. We started looking for others. Exoplanets became the next frontier. At first, we found them indirectly. watching stars wobble or dim as planets passed in front of them. Then the Kepler Space Telescope arrived and changed the game. It found thousands of planets, some rocky, some gaseous, some orbiting in that Goldilocks zone where liquid water could exist. Suddenly, the odds of other life in the universe didn't seem like fantasy anymore. They seemed like math. And with that realization, humanity's ancient instinct flared back to life. The same curiosity that made Babylonian priests map Venus now drives scientists to scan distant systems for signs of radio chatter or atmospheric biosignatures. We're still those same stargazers, only now we've traded papyrus for Python scripts. We may have lost the incense and chants, but we've kept the awe, because when a telescope picks up light from a world 100 light years away, you can't help but feel a jolt of recognition. Somewhere out there, maybe, someone else is looking back. Of course, our gaze hasn't just stayed outward, it's turned inward too. We've realized that the key to understanding the universe might lie in understanding ourselves. Every atom in your body was forged in a dying star. Every breath you take recycles stardust that once floated through a nebula. You are literally made of the universe trying to know itself. Carl Sagan put it perfectly. We are a way for the cosmos to know itself. It sounds poetic, but it's also literal. Consciousness might be the rarest and strangest phenomenon the universe ever produced, a mirror held up to infinity. And as our telescopes stretch further and our computers grow smarter, we inch closer to the edge of the knowable. Beyond that, the great cosmic shrug. Dark energy, parallel universes, time before the Big Bang. These are the new myths we tell, only this time they're written in equations instead of verse. The universe hasn't lost its mystery, it's just changed languages. And we, ever the curious primates, are still translating. Somewhere, thousands of years from now, someone or something will look back at our maps, our satellites, our digital constellations, and think of us the way we think of those ancient sky watchers in Babylon or Egypt, a species of dreamers who couldn't stop staring upward, chasing patterns in the dark, desperate to understand their place in the cosmic ocean. The tools change, the math evolves, but the instinct stays the same: to look up, to wonder, to measure the heavens with trembling hands. That's not science, that's humanity. By the 21st century, astronomy had become something the ancients could never have imagined, a global, interconnected symphony of machines peering across every wavelength of light. Radio telescopes listening to the whispers of quasars billions of light years away. Space-based observatories catching X-rays and gamma rays from violent cosmic explosions. Infrared instruments scanning through dust clouds where new stars are being born. It was no longer about seeing the heavens. It was about hearing them, feeling them, even simulating them. The cosmos had become data, and we were swimming in it. Projects like ALMA in Chile's Atacama Desert, a plateau so high and dry it feels like standing on Mars, pushed astronomy into a new dimension. With 66 giant dishes working in harmony, ALMA could resolve structures in distant galaxies so fine that it felt like the universe was under a microscope. Meanwhile, the Event Horizon Telescope, an Earth-sized network of observatories, achieved what once sounded like science fiction. It photographed a black hole. That glowing ring, that dark void at the center of galaxy M87, wasn't just a picture. It was proof that Einstein's equations work down to the very edge of reality. And then came James Webb. Launched in 2021 after decades of engineering headaches, budget overruns, and sheer human stubbornness, the James Webb Space Telescope unfolded in space like an origami masterpiece. Floating a million miles from Earth, its golden hexagonal mirrors began capturing light so ancient it predated galaxies themselves. The first images sent scientists into a frenzy. Galaxies that weren't supposed to exist that early in the universe's history were right there, glowing defiantly. The story of creation itself was suddenly up for revision. The telescope wasn't just showing us beauty, it was forcing us to rewrite the script. Every pixel it captured carried questions sharper than any answer before it. Were our models of cosmic evolution wrong? Did stars form earlier than we thought? Was the Big Bang smoother, faster, stranger than our equations suggested? It was the perfect irony. The more powerful our tools became, the less certain we were about the truth. Science hadn't killed mystery, it had deepened it. But astronomy wasn't just for scientists anymore. The same way ancient stargazers gathered in temple courtyards, modern humans now gather online. Citizen astronomers with backyard telescopes, open-source software, and cheap cameras can discover comets or spot exoplanets from their driveways. A kid with a laptop can process NASA data and find something professionals missed. The cosmos had gone open source. We'd turned stargazing into a collective human project again. Global, digital, democratic. And yet, for all our sophistication, some things never change. The same thrill that pulsed through an Egyptian priest watching Sirius rise is the same thrill that hits you when you step outside on a cold night and see Jupiter hanging over the horizon, glowing like a tiny lantern. The same sense of smallness, of awe, of connection. You could fill a lifetime with physics equations and still feel that gut-deep wonder when you realize that the light from that planet left it 40 minutes ago, racing through the dark just to hit your eyes now. Astronomy isn't just about knowledge, it's about timing. It's about being alive in the blink between cosmic seconds. And if there's one thing that defines our modern relationship with the stars, it's the tension between intimacy and scale. On one hand, we can measure the temperature of a star billions of light years away. On the other, most of us can't name more than 5 constellations anymore. Ancient farmers could tell time, seasons, and directions just by looking up. We, with all our technology, barely look up at all. The night sky is washed out by city lights, replaced by screens that glow with artificial constellations of pixels. We traded the Milky Way for Wi-Fi. Still, the urge remains buried in us. When blackouts happen and the power dies, people step outside and see the sky, really see it, for the first time in years. They gasp, they take photos, they fall silent. There's something primal in that moment, something no satellite feed or simulation can replicate. The universe doesn't care if you believe in it, but the moment you look up, it pulls you in anyway. It's strange, isn't it? We built machines that can see the dawn of time, yet what humbles us most is still that silent shimmer above our heads. The same old stars, shining on every generation that's ever dared to look up. From flint tools to fiber optics, the act of stargazing connects us across the millennia. We're still telling the same story, only now the language is quantum. And as humanity stands at the threshold of interplanetary travel, the stars are no longer unreachable icons of myth. They're destinations. Mars isn't a god anymore. It's a goal. And behind it, the great unknown stretches forever, daring us to follow. Because if history has taught us anything, it's this. The more we learn about the universe, the more it reminds us of how little we truly know. And maybe that's the point. Curiosity is the one force even gravity can't hold down. If there's a moment that defines the new age of stargazing, it's when we stopped just looking at the stars and started reaching for them. The same impulse that built sundials and temples now builds rockets and rovers. What began as myth and worship turned into engineering and logistics. We've gone from charting the heavens on stone to planning missions there with code. The human imagination didn't just map the sky. It built a bridge toward it. The space age wasn't born in peace. It began in the shadow of the Cold War, when the stars became the next battlefield. The Soviet Humanity had left the cradle. The world panicked, then dreamed. Within 12 years, Neil Armstrong's boot sank into lunar dust. That moment, one small step, one giant leap, wasn't just a victory for America. It was a victory for every stargazer who had ever wondered what it might feel like to stand under a different sky. And then silence. The great rush of Apollo faded. The moon had been conquered, the flag planted, the photos taken. The budget dried up, the cameras moved on, and humanity looked away. We'd reached the stars, and then got bored. Typical. But in the quiet decades that followed, something more profound began to happen. The dreams stopped belonging to governments and started belonging to people. Scientists, engineers, kids with posters of rockets on their walls. The cosmos became personal again. Voyager 1 and 2, launched in 1977, carried that personal touch. Each spacecraft bore the golden record, a cosmic mixtape of humanity. Whale songs, back, greetings in 55 languages, and a picture of a mother and child. Just in case someone or something out there was listening. By the time Voyager 1 took the famous pale blue dot photo in 1990, it was 6 billion kilometers away. Earth appeared as a faint speck of light, smaller than a pixel. Carl Sagan looked at that dot and said, "That's home. That's us." And suddenly, all of astronomy, every chart, every myth, every telescope, collapsed into a single truth. Everything we've ever known happened on that tiny grain of light. But we didn't stop there. The next leap wasn't just about escaping gravity. It was about escaping ignorance. Space telescopes like Chandra and Spitzer revealed the cosmos in invisible wavelengths. Probes like Cassini dove through Saturn's rings and sent back postcards from a world of ice and shadow. New Horizons flew past Pluto, turning a blur into a landscape of frozen plains and mountain ranges of nitrogen ice. Each mission felt like a new myth in the making, a continuation of that ancient story, now told in binary and telemetry instead of poetry. Then came a new breed of explorers, the private ones. SpaceX, Blue Origin, Rocket Lab. For centuries, space had been sacred, unreachable, divine. Now it was something you could book a seat on if you had the money. Rockets landed upright again. Boosters reused. Payloads launched weekly. What used to be miraculous was now just Tuesday. Humanity was industrializing wonder. And yet, even amid all the headlines about billionaires and budgets, the deeper story remains the same. Every satellite orbiting Earth, every probe crawling across Mars, every telescope scanning the sky, they're all extensions of the same ancient instinct, the same one that made a priest in Babylon measure shadows or a scholar in Alexandria blot the stars on papyrus. We keep building new tools for the same reason. We can't stand not knowing. But reaching for the stars has also forced us to confront an uncomfortable truth. Space is beautiful, but it's not friendly. It's radiation, vacuum, silence. Every kilometer beyond Earth is a death trap waiting for a small mistake. Mars, our next big dream, is basically a rusted desert at minus 80 degrees Celsius with no breathable air. The moon's dust is razor sharp and toxic to lungs. And cosmic rays? They'll turn your DNA into confetti. The cosmos doesn't welcome visitors. It tests them. Yet that's exactly why we go, because every great advance in human history has come from walking straight into danger and asking, what's next? We're explorers, not because it's safe, but because it's not. Ancient astronomers risked blasphemy to speak truth about the stars. Modern ones risk their lives to touch them. The danger, the uncertainty, the sheer impossibility of it all, that's the fuel. When you think about it, space exploration is the purest continuation of astronomy. The ancients built pyramids to align with the heavens. We build rockets to meet them halfway. They carved stories into stone. We etched commands into silicon. They dreamed of gods among the stars. We send robots instead. Different methods, same obsession. And maybe that's what makes this era so strangely poetic. For the first time, humanity isn't just watching the heavens move. We're part of the motion. Our machines orbit the sun. Our eyes drift between galaxies. Our footprints sit in lunar dust that will outlast every city we've ever built. The sky we once worshipped is now a road we travel. But here's the thing about roads. They always lead somewhere new. And where humanity's cosmic road leads next is a question that keeps every astronomer, dreamer, and engineer awake at night. Because if the stars were once our gods and then our maps, maybe, just maybe, they're our destiny. It's almost poetic, isn't it? The species that once feared eclipses as omens of doom now manufactures them on purpose in laboratories to study solar flares. The same creature that told stories about gods riding fiery chariots across the sky now pilots metal capsules through the vacuum those gods once ruled. We've rewritten the mythology, but we haven't escaped its rhythm. Every mission, every telescope, every new discovery, it's all part of our ongoing epic about light, time, and the endless hunger to understand what's out there. By the 2020s, the cosmos wasn't some distant backdrop. It was a frontier that felt startlingly close. We'd landed rovers on Mars that drilled into rocks, launched probes that surfed the tailwinds of comets, and built telescopes capable of peering back almost to the dawn of time. Humanity had become a network of eyes and ears stretching across the solar system. the ancient dream of mapping the heavens wasn't just poetic anymore. It was literal. Every crater, every orbit, every molecule of alien ice had a name, a coordinate, a data tag. We weren't just gazing, we were cataloging creation itself. But amid all the triumphs, a quiet unease lingered, because as our reach expanded, so did our realization of how staggeringly small we still are. The more we discovered, the more the universe seemed to mock our confidence. We thought we knew how galaxies form. Then Webb found them forming billions of years earlier than expected. We thought black holes were rare. Now we find them at the heart of nearly every galaxy. We thought we understood physics until dark energy and quantum weirdness laughed in our faces. Every answer was a door to 10 more questions. The cosmos wasn't a puzzle to be solved. It was a trickster, constantly rewriting its own rules. Yet maybe that's exactly why we love it, because deep down humans thrive on mystery. We need something bigger than ourselves to wrestle with. Ancient astronomers looked for gods in the stars. Modern ones look for laws of nature. Different masks, same longing. For meaning, for connection, for something beyond the daily grind. We still stare into the dark, hoping it'll stare back. And every so often, it does. The Kepler and TESS missions turned up thousands of exoplanets, some orbiting twin suns, others locked in eternal daylight where night. A few sit right in that precious Goldilocks zone where liquid water could exist. Suddenly, the idea that life might be out there stopped sounding like wishful thinking and started sounding like statistics. Billions of stars, billions of worlds. Odds are someone else is out there asking the same questions. Maybe they're staring at their sky right now, mapping our sun with instruments we can't imagine, wondering if anyone lives around that faint yellow star. The search for life beyond Earth has become the most emotional branch of astronomy. It's not about data, it's about longing. SETI listens for radio signals from intelligent civilizations, while astrobiologists analyze exoplanet atmospheres for traces of oxygen or methane. One detection, one faint signal could rewrite everything we believe about existence. Imagine that headline, "We are not alone." Religion, philosophy, politics, even identity, it would all shift overnight. The same way Copernicus dethroned Earth, the discovery of alien life would dethrone humanity from its imagined uniqueness. And yet, it would also connect us to something far greater, a shared cosmic lineage. But let's be honest, we don't have to find aliens to feel that connection. The more we learn about the universe, the more we see ourselves reflected in it. Every star is a nuclear furnace running on the same physics that powers your heartbeat. Every element in your bones was born in a supernova. Every breath you take contains atoms older than the sun. You are, quite literally, recycled starlight with opinions. When you think about it that way, astronomy isn't about looking out there at all. It's about looking inward. Still, the urge to reach outward never fades. Mars missions have become rehearsal runs for our future as a multi-planet species. Space agencies and private companies alike are designing habitats, mining systems, and even in potential cities for the red planet. Humanity, it seems, is preparing to transplant its gaze to turn another sky into home. And as strange as that sounds, it's not new. The first farmers who looked up at the stars to time their crops were already using the heavens to shape their survival. The tools have changed, but the instinct remains. The stars have always guided where we go next. Yet, as we expand, there's a subtle irony. The more we leave Earth to explore the cosmos, the more precious Earth becomes. The pale blue dot isn't just a metaphor anymore. It's a warning. From space, our planet looks impossibly fragile, a thin swirl of blue and white surrounded by black infinity. There's no border, no nation, no noise, just life clinging to a dust mote. And when astronauts return from orbit, almost all of them say the same thing. Seeing Earth from above changes you. They call it the overview effect. It's the modern version of ancient awe, the realization that everything, every human story, every god, every love, every war, exists on a single glowing speck suspended in the void. It's humbling, and maybe that humility is the truest outcome of all our stargazing. Because in trying to understand the universe, we end up rediscovering ourselves. The cosmos stops being something distant and starts being a mirror, one that reflects both our brilliance and our fragility. We used to think the stars told our fate. Now we know our choices will decide whether we get to keep seeing them. If you've ever looked at an image from the James Webb Space Telescope and felt that strange mix of awe and vertigo, that sense that you're seeing something impossibly ancient, yet somehow present, then you've touched the heartbeat of modern astronomy. It's not just about seeing farther, it's about seeing deeper. Each photon that lands on those golden mirrors has been traveling for billions of years, carrying with it the story of a universe that was still figuring out what a galaxy even was. When those photons finally strike a detector, the universe isn't whispering its secrets, it's screaming them across time. And yet, there's something almost heartbreakingly human about this enterprise. We spend billions of dollars and decades of effort to build machines that capture whispers of light from objects so distant that we'll never reach them. It's like sending love letters into the void, hoping the cosmos writes back. Every image, every spectrum, every pixel is an act of faith. Faith that knowledge, even of something unreachable, still matters. The Webb telescope didn't just show us new stars. It showed us new beginnings. Galaxies forming earlier than theory predicted. Carbon molecules floating in the atmospheres of alien worlds. Light bending and twisting around invisible masses, revealing the fingerprints of dark matter. It was as if the universe were shrugging and saying, "You thought you had me figured out? Cute." Every discovery was a reminder that our cosmic education is still in its infancy. But there's also a cultural shift at play. Astronomy used to belong to professionals, the white lab coat elite with access to mountaintop observatories and multi-million-dollar instruments. Now, with small telescopes, digital sensors, and online databases, anyone can explore the sky. Amateur astronomers discover comets. Backyard telescopes catch supernovae. Students process raw data from NASA archives and find exoplanet candidates the pros missed. The universe has been democratized. The same curiosity that drove ancient stargazers now lives in smartphones and suburban rooftops. The night sky has never been more accessible, nor more crowded with shared wonder. And then there's the rise of space telescopes, designed for the invisible. The radio, infrared, X-ray, and gamma-ray bands our eyes can't see. These instruments peel away layers of illusion. They show us a universe that's not serene and still, but violent and alive. Black holes feeding on stars, neutron stars colliding, galaxies tearing each other apart in slow-motion cosmic ballet. We used to think the heavens were perfect and eternal. Now we know they're a battlefield of creation and destruction, and somehow that makes them even more beautiful. What's most striking is how astronomy, despite its cold precision, always circles back to emotion. We start with data, photons, wavelengths, equations, and end up talking about meaning. Scientists tear up when they see the first light from a new telescope. Engineers describe launching probes as watching your child leave home. Astronauts cry silently behind their visors when they see Earth rising over the lunar horizon. You can't separate the science from the soul. They're entangled like binary stars. And beneath all that emotion, there's an undercurrent of urgency. Because for all our progress, time is not on our side. The Earth, our cradle, won't last forever. Not just because of us, though we're doing a pretty thorough job accelerating its decline, but because the sun itself will one day die. In 5 billion years, give or take, it'll swell into a red giant, boiling the oceans and devouring the inner planets. Long before that, rising solar luminosity will make Earth uninhabitable. Every astronomer knows this, even if we don't like to say it out loud. The stars we admire are also reminders that everything, even worlds, have an expiration date. That's part of why we reach outward. Mars, the moon, exoplanets. They're not just curiosities, they're escape plans, not in the sense of abandoning Earth, but of ensuring that life, consciousness, curiosity itself doesn't end here. Astronomy has always been about survival in disguise. When ancient people tracked the stars to plant crops, they were fighting hunger. When sailors used the night sky to navigate, they were fighting isolation. And when we study cosmic radiation and planetary atmospheres now, we're fighting extinction. Looking up has always been a survival instinct. But maybe, just maybe, it's also something gentler. Maybe we explore because the universe is beautiful, and beauty demands witnesses. Maybe we look up not because we fear the end, but because we love the beginning. Every nebula, every galaxy, every flickering speck in the sky is a reminder that existence didn't have to happen, and yet somehow it did, and we, improbably, are here to notice. There's a quiet line that runs through all of human history, from the first cave painter marking constellations on stone to the latest astrophysicist aligning a telescope. We are trying to see ourselves in the stars. The more we gaze outward, the clearer that reflection becomes, not because the cosmos resembles us, but because the act of seeking, of wondering, is what defines us. In a universe that's mostly empty, that curiosity is our spark, our defiance, our light. For all our cleverness, though, the cosmos still has the upper hand. Every time we peel back one mystery, 1,000 more open up like a Matryoshka doll of cosmic riddles. We found dark matter, or rather, we found that something must be there, but we have no clue what it actually is. It doesn't glow, it doesn't interact with light, it doesn't seem to care that we exist. It's like a cosmic ghost making up most of the universe, silently shaping galaxies while giving us the ultimate cold shoulder. And then there's dark energy, that invisible force pushing everything apart faster and faster. It's the universe's way of saying, "Oh, you thought you understood gravity? Adorable." We're surrounded by mysteries that account for 95% of everything, and yet we strut around bragging that we know the universe. It's like reading one word of an epic novel and claiming you've mastered the plot. Still, that's the charm of it, isn't it? The unknown isn't a barrier, it's an invitation. Humans have always thrived on not knowing. That's why, even as telescopes stare into the deep field, others turn inward, studying how ancient stargazers managed such uncanny precision with none of our technology. Because maybe, just maybe, they knew something we've forgotten, not in equations, but in perception. Ancient astronomers watched with patience we can't even imagine. They tracked stars by memory, intuition, and ritual, forming relationships with the sky. They didn't have data, they had devotion. And that devotion didn't die. It evolved. It slipped quietly into cathedrals, observatories, and planetariums. Gothic churches, with their rose windows, were architectural prayers to geometry and light. Stone telescopes fixed toward heaven. Medieval monks kept astronomical tables alongside biblical manuscripts, convinced that to chart the stars was to read God's handwriting. Even as science split from theology, that longing remained. When Galileo pointed his telescope upward, he wasn't just collecting data, he was searching for meaning. When Newton described gravity, he wasn't just explaining orbits, he was uncovering order in chaos. Astronomy was, and still is, the most spiritual of sciences, even when stripped of gods. But then came a twist no one saw coming. The machines began to see for us. Digital detectors replaced eyes. Algorithms sifted through billions of stars faster than any human could. Artificial intelligence now hunts exoplanets, analyzes spectra, even predicts supernova. The universe has become too vast for any single human to grasp, so we've outsourced our curiosity to circuits. And here's the irony. The more data we gather, the more alien the cosmos becomes. Our machines see more than we ever could, but they don't wonder, they don't feel awe, they don't stare into the Milky Way and whisper, "What if?" They just calculate. We've gained clarity, but we've lost a bit of intimacy. Still, there's something poetic about it. Machines are, in a way, our new apprentices, built in our image, programmed to continue our cosmic detective work. Every satellite, rover, and telescope is a metal monk, silently orbiting or crawling across alien landscapes, carrying our curiosity like sacred fire. When Voyager's golden record was launched, that tiny time capsule with greetings, music, and images of Earth, it wasn't just data. It was a love letter to whoever might be out there, or to no one at all. Maybe that's the point. The gesture itself is enough to send something into the abyss and say, "This is us. We looked up." Meanwhile, back on Earth, light pollution spreads like a slow cosmic amnesia. In most cities, you can't even see the Milky Way anymore. The sky that once guided farmers, priests, and philosophers has been drowned in a sea of sodium glare. Billions of people will live their whole lives without ever seeing a truly dark sky, without realizing that the universe is right there, shimmering above the noise. And yet, in remote deserts, atop mountains, and in protected reserves, a few pockets of darkness remain. People travel halfway across the world just to stand under a sky unspoiled by civilization and feel that ancient hum return. They gasp, they cry, they go silent. For a moment, every modern distraction falls away, and they become the same as those who once watched from ziggurats and pyramids. Small, awestruck, human. We forget sometimes that astronomy isn't just about stars. It's about perspective. Every discovery reminds us how fragile we are, how temporary, but also how astonishing it is that we can understand anything at all. We're apes that figured out how to measure the speed of light, how to map the invisible, how to trace the birth of the universe itself. Against all odds, we've dragged meaning out of chaos. That's not arrogance, that's poetry. And yet, we keep asking, are we alone? The question refuses to die. Every exoplanet discovered, every strange radio signal recorded, every molecule of organic material found on Mars or Titan adds another layer to that haunting curiosity. Maybe life is everywhere, scattered like stardust. Maybe it's rare, a cosmic accident that happened once and never again. Either way, the search defines us. Because if we ever find even a whisper of another intelligence, it won't just change how we see the universe. It will change how we see ourselves. Until then, we keep looking outward, outward, forward. Our machines humming, our telescopes blinking, our hearts full of questions. Because deep down, we know that the night sky isn't a map of distant suns. It's a mirror of our own longing, our need to belong to something bigger. The cosmos doesn't need us, but we need it. We always have. So here we are, a species suspended between atoms and galaxies, trying to chart infinity with tools built by hands that once chipped flint. It's almost comical if you think about it. We map the cosmos, and yet we can't even fully map the human brain. We send telescopes 1,000,000 miles away, but lose our keys in the morning. Still, something inside us insists on reaching higher, on building one more instrument, one more observatory, one more dream. It's obsession, yes, but it's also identity. To look up is to remember what we are, curious creatures in a universe that owes us no explanation, yet keeps offering one anyway. The search for order in the stars has always mirrored the search for order within ourselves. Every cosmic model, every calendar, every theory of orbits reflects how humans understand time. The Babylonians carved cycles of Venus to predict omens. The Mayans aligned temples to solstices. The Greeks imagined crystalline spheres turning in perfect harmony. Then Newton shattered that harmony into a clockwork of laws, and Einstein bent the gears until time itself curved. Now physicists chase quantum whispers, and somewhere between all these layers, we realize the truth. Time isn't a line, it's a rhythm, and we've been dancing to it since we first looked up. That rhythm pulses through history's greatest observatories. The massive domes perched on mountaintops, Mauna Kea, Paranal, Kek, La Palma, are cathedrals of precision. Their mirrors flex ever so slightly to cancel atmospheric tremors. Their domes rotate like mechanical hearts tracking the heavens. Astronomers spend nights inside them like monks in meditation, whispering coordinates instead of prayers. Outside, wind and frost batter the metal. Inside, equations unfold like psalms. You can almost hear the continuity, the same devotion that guided Egyptian priests and Chaldean watchers now runs through fiber optics and computer screens. The faith is different, but the reverence is the same. And yet, no matter how advanced our instruments become, the stars remain just out of reach. We measure them, name them, catalog them, but we can't touch them. That distance is what keeps the wonder alive. It's why the ancients turned stars into gods and why modern scientists turn them into data. Both are ways of coping with the unreachable. Maybe we need that gap between us and the cosmos, the reminder that some things are meant to stay beyond grasp. Because if we ever solved it all, if we knew every constant, every particle, every mechanism of existence, what would be left to chase? The universe without mystery would be a tragedy. Still, we try. Every generation pushes a little further, builds a better clock, a sharper lens. From Stonehenge to the Hubble, the same thread runs through it all. A stubborn refusal to stop asking why. And that thread now stretches beyond Earth entirely. We send probes to icy moons, rovers to red deserts, telescopes beyond the atmosphere. Our species, born in mud and fire, has left fingerprints on other worlds. And the best part? We've only just started. Future astronomers will work from lunar bases, telescopes floating at Lagrange points, maybe even observatories orbiting other stars. The sky isn't the limit anymore. It's the starting line. But progress comes with a shadow. The more we conquer, the easier it is to forget the humility that began it all. Ancient stargazers didn't study the sky to dominate it. They studied it to belong to it. Their rituals, calendars, and myths weren't about control. They were about connection. Somewhere along the line, We replaced awe with ambition. The stars became targets instead of teachers. Yet the universe doesn't bend to ego. It humbles everyone eventually, even the brightest minds. Every new discovery rewrites the last one. Every final theory becomes just another chapter. The cosmos never stops reminding us that we're temporary guests in an eternal drama. And that's okay. In fact, it's perfect. Because being temporary makes the experience urgent. Every generation gets only one turn under the stars, one lifetime to watch, to measure, to wonder. The sky you see tonight is a painting in motion, already changed from yesterday, already older than you realize. Some of those lights you admire are ghosts, their stars long dead, their photons still traveling to reach your eyes. When you look up, you're literally watching time itself, the universe's own memory. So, what are we left with after millennia of stargazing? Patterns on papyrus, gears of bromes, data on screens, but also something far less tangible, a feeling. That quiet, electric awareness that we're part of something vast and intricate and alive. The ancients called it the divine. We call it physics. But maybe it's the same thing viewed through different lenses. Whether carved in stone or coded in binary, it's the same message repeated across time. We are here and we are looking. And somewhere out in that endless expanse, the universe is looking back, maybe not through eyes or thoughts, maybe just through existence itself, because every star that burns, every planet that forms, every heartbeat under the sky is part of one ongoing conversation. And we, the stargazers, the clockmakers, the dreamers, have always been its translators. When you step back far enough, the entire story of humanity could be told as a single gesture, a hand lifting toward the sky. From the first ancestor who squinted at the constellations and thought they saw a pattern, to the engineers who send robots to dance among Martian dust. It's the same impulse, to reach, to understand, to belong somewhere in the grand architecture of light. We've built our civilizations in that reflection. The sky gave us calendars, myth, navigation, hope, and fear. It shaped how we see gods, and later, how we see ourselves. Every temple, every observatory, every telescope is an echo of that first moment of wonder, frozen in stone and steel. Think of what that means. Civilizations have risen and fallen, languages have vanished, empires have turned to dust, and still people look up. The stars above Babylon are the same ones that glittered above the Mayan jungles, above the Nile, above you tonight. Empires rewrite maps, but the constellations remain loyal only to time. They remind us that we are not the center of anything, yet somehow part of everything. That paradox, being small yet significant, is what keeps us going. Because if the cosmos could produce something as fleeting as us, maybe fleetingness itself has meaning. The ancient astronomers who built their celestial clocks in stone didn't just track the heavens. They declared a relationship with them. They watched stars rise and fall like the breath of the gods, and believed that understanding that rhythm brought them closer to order. We've replaced gods with galaxies, myths with math, yet the yearning hasn't changed. When we build our orbital telescopes or map the microwave afterglow of creation, we're still whispering the same question that echoed from every ziggurat and temple. Why are we here? And maybe the answer lies not in the equations, but in the act of asking. The universe doesn't need meaning. It just is. But we, fragile creatures on a spinning rock, make meaning by searching for it. That's what the stargazers of old did when they etched their observations into papyrus and stone. They didn't just map the sky, they mapped their souls. Every alignment, every glyph, every number carved into granite was a message forward, a record saying, "We saw, we wondered." Their clocks were more than instruments. They were promises to the future. Today, our instruments are colder, sleeker, digital, but the promise endures. Voyager still sails into the dark, carrying our sounds and images. The James Webb peers into the first dawn. Even the smallest backyard telescope, humming under suburban skies, continues that same dialogue with eternity. We are not watching the universe from the outside. We are watching it from within. Every atom in your body was born in a star. You are, quite literally, stardust learning to see itself. That's not poetry. That's physics wearing a soul. And perhaps that's the great secret all along. The cosmos doesn't care if we measure it or mythologize it, if we worship it or dissect it. What matters is that we notice that somewhere on a small blue planet, consciousness evolved to the point where it could look up and say, "That's beautiful." Every observation, every theory, every moment of awe is part of the universe becoming aware of itself. When you look at the night sky, you are both observer and participant, the witness and the witnessed. The act of looking gives the cosmos a mirror. So, when the lights go out tonight, really out, no screens, no noise, step outside for a moment. Let your eyes adjust. Find a patch of sky and just stare. Somewhere out there, photons from stars long dead are landing on your retina, completing a journey millions of years old. You are the final chapter in their story. The same light that guided Egyptian priests, Mayan astronomers, and Polynesian navigators now reaches you. You are part of that unbroken chain of curiosity stretching across millennia. And that's the quiet truth buried beneath all the math, myth, and machinery. We map the stars not to control them, but to remember who we are. Every civilization that looked up wrote its own reflection into the heavens. Stories of gods, heroes, lovers, and monsters. Our stories just use different names: pulsars, quasars, wormholes, black holes. The language changes, the wonder doesn't. The sky remains the great constant, the original scripture written in light. So here's to the stargazers and the clockmakers, the dreamers with stone tablets and silicon sensors. Here's to every person who ever lost sleep, staring at the night sky, trying to make sense of its vast indifference and its quiet kindness. We've come a long way from marking shadows on sundials, but the question that drove it all still burns as fiercely as any star. What is out there, and what does it say about us? Maybe, in the end, those are the same thing. The universe isn't just something we study, it's something we're part of. A vast conversation between matter and meaning. And as long as there are eyes to see and minds to wonder, that conversation continues. So keep looking up, because the moment we stop, the universe goes silent, not because it vanishes, but because we do.